let's set course for the constellation Aquarius, where an ultra-cold red dwarf, TRAPPIST-1, reigns over not one, but 7 exoplanets. The idea of discovering any trace of life on just one of these planets would already be extraordinary. However, in February 2017, the discovery of this planetary system, at a distance of around 39 light-years from Earth, reinforced this hope. In fact, 7 rocky planets, almost the same size and mass as our Earth, orbit this star. Their orbits are all smaller than that of Mercury with our Sun. These planets are so close together that they sometimes seem to brush against each other. Such close proximity to the host star could be cataclysmic for these planetary objects. This is an M-type star, much cooler than our Sun, with an estimated mass of 9% of the Sun's mass. Of these 7 planets, 3 are located in the habitable zone and could harbor liquid water. These are TRAPPIST-1e, 1f, and 1g, the latter being the best place of all in this habitable zone. This system is therefore one of the most studied by scientists, especially as the proximity between these 7 planets could be conducive to potential panspermia. This means that life plants would be able to circulate from one planet to another via extraterrestrial contamination. As Chandra Wickramasinghe of Buckingham University explains, in such a planetary system, the exchange of bacteriological life is almost inevitable. But let's go inside this magnificent system and take a closer look at TRAPPIST-1f, the 5th planet, this promising super-Earth that seems to have turned its gaze toward its star. As you may have noticed, due to synchronous rotation, all planets invariably present the same face to their star. But unlike the other planets, TRAPPIST-1f is not completely covered by a thick mantle of ice or volcanic oceans. Locked in, like its companions, by the tidal forces emanating from the star, it would even have a strange physiognomy, strangely resembling an eye. Most of the planet, least exposed to the red dwarf's rays, would resemble a cracked mosaic. This cold, austere world, covered in ice and plunged into perpetual darkness, would have abundant water networks flowing through countless fissures. On the other hand, the part of the planet constantly exposed to the sun would be ice-free and might even contain an ocean, albeit in a vaporous state. Under these conditions, is it legitimate to hope to find any form of life there? Because of its distance from the sun, its average equilibrium surface temperature is minus 54 degrees Celsius or minus 65 degrees Fahrenheit. Could there be a ribbon of habitability between these two zones of extreme conditions? Could there be a termination line with temperatures conducive to the existence of liquid water? In the best-case scenario, is there enough atmosphere to even out these temperature mismatches and provide conditions conducive to the emergence of life? Observations of this system with the Hubble telescope have enabled us to measure the amount of ultraviolet radiation emitted by the star. These have a considerable influence on the evolution of planets, and consequently, on the presence or absence of water on them. The closest planets could have lost abysmal quantities of water, while TRAPPIST-1f and its two neighbors would have been much less impacted. Optimism, albeit measured, is the order of the day, allowing us to imagine that the appearance of life in these distant horizons could be envisaged. As you know, many civilizations have worshipped the sun. Imagine a planet where two suns shine brightly, giving you a double sunset. In fact, this fantastic vision is reminiscent of a scene from the famous Star Wars saga. Remember Tatooine, the birthplace of the famous Skywalker, where two suns light up the sky? But let's step out of fiction and join Kepler 16b, a planet also known as circumbinary, which actually exists. Discovered in 2011 using data gathered by the Kepler Space Telescope, its existence was detected using the radial velocity method. Located in the constellation Cygnus, 245 light-years from Earth, it has no astonishing features. It is a cold gas giant, comparable to Saturn in size and mass, with a radius around 75% that of Jupiter. This planet, a priori, made up of as much gas as ice mixed with rock, has an equilibrium temperature of around -100 degrees Celsius or -148 degrees Fahrenheit. It orbits in just over 228 days with a semi-major axis of around 104 million kilometers or 64 million miles from the barycenter of its two host stars. But its singularity, as you may have guessed, is due to the fact that it orbits a binary star system. The two stars orbit each other in 41 days. The more massive star is an orange dwarf of spectral type K. The second, less massive and less luminous, is a red dwarf of spectral type M. Imagine what sunsets can be like on this planet, bathed in a more or less diffuse fog. The entire sky must be adorned in orange hues, giving the impression of an infinite celestial fire. For scientists, this discovery has confirmed the existence of circumbinary planets, and thus demonstrated the astonishing diversity of celestial bodies residing within our galaxy. But even stranger still, these two stars, in their cosmic dance, take turns masking each other, thus qualifying as an algol-type eclipsing binary star. Unlike binary systems composed of relatively similar stars, these two stars are very different from each other, the red dwarf being 3 times smaller and lighter than its neighbor, the orange dwarf. When the red dwarf passes in front of the orange dwarf, it partially eclipses the latter. Conversely, the more massive and voluminous orange dwarf completely obscures its companion. During this short time, a single sun seems to pour its rays onto the planet. Because of its composition, this duo doesn't really fit with the original definition of a binary star. According to the latter, a true double star results from the union of two stars formed together in the same system by the laws of gravitation. Be that as it may, this flamboyant duo offers a spectacular sight when placed in our line of sight, with the planet Kepler 16b in the foreground. However, this is not the most marvelous sight a planet can offer us. Still in the constellation Cygnus, in a slightly less distant region, just 150 light-years from our Sun, a planet whose discovery was announced in 2005 presents an even more spectacular panorama. Imagine contemplating the stars alongside this one and perceiving the last fiery rays of an immense sun about to disappear behind the horizon, while two other stars, modest in size and much warmer in hue, still illuminate the rocky peaks of a nearby lunar satellite. Isn't it a breathtaking sight? We're close to the hot planet HD 188753AB, which, as you'll have guessed, is part of a triple star system. Until 2005, the idea that a planet could form in a gravitational system as complex as that of a triple system was merely a hypothesis. The detection of HD 188753AB would have confirmed that planets can be far more resilient under extreme conditions than scientists had previously imagined. This hot, Jupiter-type exoplanet orbits in the vicinity of two stars that revolve around each other in 156 days, themselves revolving around a central star in just over 25 years at a distance of around 12.3 astronomical units. As a result, these three suns evolve in an area so small that our own solar system couldn't fit inside them. Indeed, their living quarters are no larger than the distance separating Saturn from our Sun. Scientists previously believed that hot Jupiters came to life in thick disks of material, far from their host star, before moving closer to it on the tides. HD 188753AB, a priori 14% more massive than Jupiter, would orbit the main star in just over 3 days, exactly 80 hours. 20 times closer to the main star than our Earth is to the Sun, this exoplanet would be only 8 million kilometers or 5 million miles away from the massive star. The reason I'm using the conditional tense to describe this exoplanet is that in reality, it has never been directly observed. Its presence has been suggested by measurements of the radial velocities of the triple system. Following the announcement of its detection by Polish astrophysicist Konaki, a European team of scientists claimed to have carried out the same measurements but failed to find it. For the time being, NASA has yet to confirm its actual presence, but who knows? Perhaps the existence of such a planet will soon be confirmed in this or any other system. After all, if its presence can't yet be truly confirmed, there's nothing to suggest otherwise. Let's continue our journey. I now propose that we reach a terrifying exoplanet which seems to harbor jewels that many would dream of possessing. Let's head for the constellation of Cancer, more precisely for the system of the star 55 Cancri, more commonly known as Copernicus. This double star, some 40 light-years from Earth, is composed of a yellow dwarf similar to our Sun and a red dwarf. Above all, 5 exoplanets orbit around them, including 55 Cancri e, discovered in 2004. Let's get closer to the latter while keeping a reasonable distance. Indeed, this planet orbits at a very short distance from Copernicus, its star similar to our Sun, from which it is only 2.24 million kilometers, or 1.5 million miles away. To give you a comparison, this represents approximately 20% of the average distance between Mercury and the Sun. As you can see, this planet's surface resembles a blazing inferno. Given its proximity to its host star, it's subjected to extremely high temperatures, hence its molten volcanic surface, completely covered in incandescent lava. Take a look at its many erupting volcanoes, spewing streams of lava across its surface. Clouds of steam and gas envelop this hellish planet, whose atmosphere is particularly turbulent and chaotic. 55 Cancri E seems straight out of a science fiction universe, with extreme conditions that defy our imagination. Its surface temperature is estimated at 2,500 degrees Celsius, or 4,500 degrees Fahrenheit, and its orbital year is incredibly short, at just 18 hours. And yet, this super-Earth is very real and of great interest to scientists, not least because of its unusual composition. With a radius estimated at twice that of the Earth and a mass around 8.6 times that of the Earth, 55 Cancri E has a very high density, suggesting that it could contain a significant metallic core. Indeed, its density of around 10.9 grams per cubic centimeter is close to that of lead. Given these exceptional characteristics, an international team of scientists came up with a mind-boggling hypothesis. In 2012, these researchers suggested that 55 Cancri E might be partly composed of diamonds. This idea, preposterous at first glance, stems from the fact that its host star, unlike our Sun, contains more carbon than oxygen. As a result, large quantities of iron, silicon carbide, and carbon, such as graphite and diamond, must have been present when 55 Cancri E was formed. Based on the mass of this super-Earth, scientists have estimated that a third of it, the equivalent of 3 Earth masses, could be composed of diamond. Imagine if we could cut open this planetary object. Beneath its crimson surface of molten graphite, a thick layer of glistening diamond would be revealed, like a river of diamonds in its dark velvet case. This extravagantly concealed shell would itself encompass a layer of silicon, including other minerals, and at its center, an inner core of molten iron. Unfortunately, this treasure remains inaccessible to ordinary mortals, both because of its remoteness and the impossibility of getting close to it. Too bad, isn't it? But before we burn our wings, let's leave this inferno and go to a far more pleasant world. This is Kepler 186f, an exoplanet located in the constellation Cygnus, some 500 light-years from Earth. As you can see, this planet is much more hospitable from the outset. Apart from its sandy beige hues, it looks very much like our beautiful blue planet. Beyond its appearance, it possesses many characteristics similar to our Earth, so much so that some consider it a potentially habitable exoplanet for human beings. Its discovery, confirmed in 2014, was made possible by the extensive data collected between 2009 and 2013 by NASA's Kepler Space Telescope. Kepler 186f is the first exoplanet to be discovered with a size almost identical to Earth, orbiting in the habitable zone of its host star at a distance of 52 million kilometers. Kepler 186, a red dwarf about 500 light-years from Earth, forms a planetary system of 5 planets. All are Earth-like in size, but Kepler 186f is the only one to be found in the habitable zone, its companions being far too close to their star. While there are many planets orbiting in the habitable zone, very few meet the essential criterion of being rocky. In fact, scientists usually discover low-density megaplanets composed mainly of gas, instead of gas giants. Kepler 186f with a radius 1.1 times that of the Earth is very likely to be a telluric planet. If a landing were possible, we would undoubtedly discover majestic mountain ranges and oceans separating various brown continents. The sun, half our size, would bathe us in daylight with its soft reddish rays without dazzling us. This constant mildness, due in particular to the absence of seasons, can be explained by the fact that the planet's rotation period is totally synchronized with its length of revolution, which is 130 days. Quite a nice environment, isn't it? But what is it really like? Does this planet have the necessary atmosphere to make it hospitable to our form of life? Observing this distant planet remains difficult for scientists, who for the time being can only speculate. However, their repeated simulations maintain the hope that an atmosphere compatible with liquid water is possible on Kepler 186f. What's more, the probability that it is indeed a rocky planet is sufficiently high. Could this be our second home? Before we left, I promised to surprise you throughout our journey. Now I'm offering you the chance to observe a planet straight out of the imagination of science fiction scriptwriters, a reverie that has since become reality. This is Gliese 1214b, an exoplanet sometimes nicknamed Waterworld, and with good reason. Discovered in 2009 in the Ophiuchus constellation, this is the first ocean planet to be completely covered in water. Its overall bluish hue is explained by its essentially aquatic composition. The light emanating from its host star, diffused through its dense atmosphere, is refracted by these infinite expanses of ocean, creating a soft, peaceful atmosphere. Detected by its 38-hour orbit around its host star, a red dwarf some 47 light-years from Earth, scientists were almost certain that it had an atmosphere. After studying this strange exoplanet more closely, using the James Webb Space Telescope in particular, they confirmed this hypothesis, and even concluded that it is dominated by water molecules. Unlike Neptune, this atmosphere is not made up of hydrogen and helium, but of heavy elements, in particular, water vapor particles. But this planet is even more atypical when we look at the distribution of its components. This is not a rocky planet on which sea levels have risen, as in Kevin Costner's feature film Waterworld. No, Gliese 1214b is 50% water, whereas our Earth's total mass is only 0.1%. This planet is therefore a new kind of planet, not related to either telluric or gaseous planets. This super-Earth has a diameter 2.7 times that of Earth, and a mass between 5.5 and 7.5 times greater. However, Gliese 1214b cannot support life as we know it, even if we consider only marine species. Its surface temperature is far too hot, reaching 200 degrees Celsius or 392 degrees Fahrenheit. What's more, its 200-kilometer or 125-mile thick atmospheric layer reinforces the greenhouse effect twice as much as on Earth. Finally, the enormous atmospheric pressure suffocates the planet. These extraordinary characteristics certainly shape water molecules, which agglomerate in the form of ice at high pressure. Although attractive at first glance, Gliese 1214b is a long way from offering visitors a warm welcome. But scientists don't despair. While the existence of these phantasmatic planets has been proven, researchers believe they are probably more common than previously thought. Indeed, among the thousands of planets detected of similar mass and size to this one, there could well be an ocean planet around every other star in the universe. But do you know the first exoplanet whose atmosphere was detected live by the Hubble Space Telescope? It's HD 209458b, nicknamed Osiris, an exoplanet that could almost be mistaken for a comet. Its discovery dates back to 1999, when it transited in front of its host star, a star similar to our Sun in the constellation of Pegasus, some 150 light-years from our solar system. Although Osiris could not be directly observed at the time, its presence was demonstrated by a change in the brightness of the star, HD 209458, occurring regularly every 3.5 days. Then, in 2007, the spectral lines of Osiris were observed directly using the Hubble Space Telescope. For the first time, the spectrum of an exoplanet could at last be precisely dissected. Thanks to an innovative process, NASA has declared that it is able to characterize the chemical composition of its atmosphere and consequently of many other extrasolar planets. But let's take a look at Osiris, a gas giant 200 times more massive than our Earth. With an orbit of just 3.5 days, it is evolving in close proximity to its star with disastrous consequences. Circling at speeds of over 500,000 kilometers per hour, or 310,000 miles per hour, it is subject to surface winds of up to 10,000 kilometers per hour, or 6,200 miles per hour. Barely 7 million kilometers, or 4 million miles from its star, 1/8 of the orbit separating Mercury from our Sun, its surface temperature exceeds 1,000 degrees Celsius, or 1,830 degrees Fahrenheit, on its immutably exposed face. These characteristics are at the origin of the plume it exhibits, like a comet releasing copious amounts of hydrogen. Osiris, this overheated gas giant, is living a veritable hell. Enveloped in a dense, hazy atmosphere with dominant hues of orange, red, and yellow, it's easy to make out the swirls of clouds that stretch across its surface and beyond. In this tumultuous, hellish landscape, it's easy to imagine the gigantic storms that reign here, punctuated by flashes of light, piercing this moribund atmosphere. The fact that this atmosphere includes free, even ionized oxygen and carbon atoms, right down to its outermost layers, has taken scientists by surprise. With a mass up to 10 times greater than that of hydrogen, how are they ejected from the deepest layers of the atmosphere? Hydrogen, the most abundant element in Osiris's atmosphere, is forcibly ejected by the star's heat and radiation in a stream strong enough to carry the heavier particles with it. According to astrophysicists, Osiris could be losing at least 10,000 tons of hydrogen gas every second. The planet has certainly already lost a significant part of its initial mass. Eventually, it may even be stripped of all its mass, leaving only a dense, inert crimson residue. This probable fatal outcome suggests to scientists the existence of a new planetary type. Is Osiris in the process of becoming a Chthonian planet? In other words, a rocky or metallic core of a gas giant planet whose atmosphere of helium and hydrogen has completely evaporated? This breathtaking spectacle is extremely intriguing, isn't it? In 2006, another planet was discovered with an orbit even shorter than that of Osiris. Dubbed the planet of eternal night by NASA, this is the darkest planet ever discovered orbiting a star. Meet TRES 2b, also known as Kepler 1b. This exoplanet, lurking in the Dragon constellation, 700 light-years from our Sun, looks like a coal ember on the verge of extinction. We won't attempt to enter its atmosphere, which is incapable of revealing anything other than total darkness. All the more so as it is incredibly hot, with temperatures reaching 1100 degrees Celsius or 2000 degrees Fahrenheit. The gas giant's lava-hot atmosphere is due to its proximity to the G-type yellow dwarf star, which holds it in place by gravitational force. It turns out that this exoplanet is literally red-hot by its host star, from which it is only 5 million kilometers, or 3 million miles away. It takes just 2.5 days to complete a full orbit around its sun. Despite being bathed in the fiery rays of the yellow dwarf it orbits, this hot, Jupiter-like planet seems to absorb them almost entirely. Only a faint reddish glow emanates from this dark, mysterious object. With a mass of 1.49 Jovian masses, the planet's ability to reflect light is practically nil. To explain this peculiarity, scientists carried out new measurements using the Kepler satellite to calculate its geometric albedo, or reflection rate. This proved to be the lowest ever recorded, at less than 1%. Even a simple lump of coal would reflect more light. For the researchers behind this study, published in 2011, only the beginnings of an answer are conceivable. It is well known that hot Jupiter-type objects belonging to Class 4 of Zadarsky's classification must have a bond albedo of less than 3%. This is due, on the one hand, to the absence of reflective clouds in their atmosphere, the latter being the result of the condensation of volatile compounds such as ammonia. On the other hand, the presence of alkaline metals such as sodium and potassium vapors and gaseous titanium oxide has been detected. These are highly absorbent compounds. However, these characteristics solve only part of the TRES 2b enigma. The models we have carried out all indicate that its geometric albedo is 1 or even 2 orders of magnitude below the established theoretical value. For the time being, this dark monster doesn't seem willing to tell us more. Now let's discover a planet that strangely enough contains hot ice. You heard right, we're talking about a state of water particles that doesn't fit in with what you might have learned in your first physics lessons. We're used to saying that ice, when subjected to temperatures above 0 degrees Celsius or 32 degrees Fahrenheit, is supposed to melt and turn into water, or even evaporate at higher temperatures. It turns out that an exoplanet the size of Neptune, weighing around 22 Earth masses, could well be made up mainly of an exotic form of water. To observe it, let's go to the constellation Leo, 33 light-years from our Sun. Meet Gliese 436b. Its discovery, announced in 2004, was made thanks to the Hubble Space Telescope. This exoplanet is easily recognizable in this part of the cosmos, as it too has a comet tail. Its oxygen-rich hair is almost 50 times the size of the planet, a phenomenon never before observed on such a small exoplanet. Gliese 436b orbits just 4 million kilometers, or 2.5 million miles from a red dwarf, circling its host star in 2.6 days. Its highly elliptical and consequently eccentric orbit makes it all the more interesting for astronomers studying orbital dynamics and planet-star interactions. Nevertheless, invariably exposed to its heat, this hot, comet-like Neptune is constantly boiling. Scientists estimate that it loses around 1,000 tons of gas per second, and that over its 6 billion years of existence, it has lost 10% of its atmosphere. But the planet's strangest peculiarity lies in its bowels. According to planetary atmospheric models, any cosmic object containing a mixture of hydrogen, carbon, and oxygen, when subjected to temperatures of up to 726 degrees Celsius or 1,340 degrees Fahrenheit, should also contain a significant amount of methane and a lesser concentration of carbon monoxide. Thanks to data collected by NASA's Spitzer Space Telescope, we now know that this hot planet lacks methane, despite a temperature in excess of 526 degrees Celsius or 980 degrees Fahrenheit. Researchers believe that Gliese 436b is too compact to be composed mainly of hydrogen gas, as is Jupiter, but it's probably not compact enough to resemble a rocky super-Earth. For the time being, only one deduction has been suggested. Gliese 436b is thought to be mostly made up of an exotic form of water. This would be ice hardened not by a sufficiently low temperature, but by the incredible pressure of the outer layers undergone by the particles. Nestled between a hypothetical rocky core and its gaseous envelope of hydrogen and helium, an enormous ocean of water, compressed to the point of becoming as solid as ice, would be preserved in this planet. Gliese 436b thus offers a multitude of enigmas to solve and phenomena to study, all the more so as its proximity to Earth on a cosmic scale makes it a prime target. One of the strangest planets in our universe is still in the spotlight. Discovered in 2007, this extraterrestrial planet in the constellation Libra, just 20 light-years from our Sun, could well be the future destination of adventurers eager to explore a new habitable world. Make no mistake, the planet standing before you is not our beautiful planet Earth, although it does bear a striking resemblance to it. This is Gliese 581c, one of 6 planets orbiting a red dwarf, one of which, like Gliese 581d, lies within its habitability zone. With a mass 5 times that of our Earth, it has all the essential characteristics for the potential appearance of life. In particular, its close distance to the red dwarf, which is much cooler than our Sun, gives it a surface temperature estimated at between 0 and 40 degrees Celsius, 32 and 104 degrees Fahrenheit. Gliese 581c is therefore capable of sustaining oceans of liquid water, an essential constituent for the emergence of life. But there's a downside to this exceptional discovery. If you look closely, this planet, 11 million kilometers or 7 million miles from its star, completes its orbit in just 13 days. And this configuration is not without consequences. Gliese 581c rotates synchronously with its star due to the tidal effect, which is 400 times greater than the tidal force exerted by the Moon on our Earth. This means that the planet has 2 completely different opposing faces. One of them is perpetually turned towards its Sun, while the other always faces the interstellar immensity. As a result, one part of the planet is permanently exposed to the luminous irradiation of its red dwarf, never experiencing the lull of night, and even worse, burning brightly. On the other side, the cosmic cold transforms its surface into a thick icy mantle. And yet, between these two sides, which endure extremely antinomic conditions, a narrow strip forms a territory where life could well emerge, and why not already exist? And this idea is far from far-fetched. In 2008, a radio signal entitled "A Message from Earth" was sent from our planet in the direction of Gliese 581c. The signal is expected to reach this intriguing and promising blue planet around the year 2029. I leave it to you to imagine the amazement, infatuation, or fright this signal could provoke, should we receive a response in return in a few decades' time, or even a visit from extraterrestrials. This is reminiscent of the scenario in Battleship, a 2012 science fiction film in which aliens from Gliese 581c attack Earth after receiving one of our messages. In the end, lingering around this other blue planet might not be the best thing to do. You're probably wondering about it too. Too much curiosity could well cut us off from a protective critical spirit. But let's leave this glittering land of welcome behind us. Illusory for the moment, it nevertheless holds out hope for the future discovery of a world equivalent to our Earth. All the more so, as the discoveries made in recent years have continued to shake us to our foundations. One of them concerns a gas giant discovered in 2009, whose properties continue to boggle the mind. Introducing WASP-17b, a hot Jupiter-like exoplanet whose dimensions at the time of its detection proved incredible. Located in the Scorpio constellation, over 1,300 light-years from the Sun, this gas giant orbits an F-type star. While its mass is almost 80% that of Jupiter, its radius is 1.5 to 2 times that of Jupiter, the largest planet in our solar system. For scientists, this discovery has once again broken the law concerning the sizes that can be reached by such an object in our universe. In theory, WASP-17b shouldn't exist. The unusual dimensions of this planet remain a mystery, unable to be explained by established models of planetary evolution. This gas giant is so swollen that its density, estimated at 0.17 grams per cubic centimeter, is only 13% that of Jupiter, or 70 times less than that of our planet Earth. By comparison, WASP-17b is less compact than a marshmallow with a density of 0.21 grams per cubic centimeter. As a result, this exoplanet is one of the lightest objects of its type ever discovered. What's more, with a radius of around 130,000 kilometers or 80,000 miles, this gigantic cosmic marshmallow completes a full rotation in just 3.7 days around its sun, only 7.7 million kilometers or 5 million miles away. But even more surprisingly, this planet behaves in a totally unexpected way, displaying a retrograde and a priori eccentric orbit. This means that it rotates in the opposite direction to its neighboring star. This configuration is probably at the origin of its unusually low density, as the planet is subject to strong tidal effects. Even more mind-boggling, data captured on March 12th and 13th, 2023 by the MIRI instrument on the James Webb Space Telescope, a cutting-edge piece of mid-infrared equipment led to an unimaginable discovery. Researchers have announced the first-ever detection of quartz nanocrystals in clouds in the upper atmosphere of WASP-17b. Silicates have already been detected in the atmospheres of other exoplanets, but this is the first time that a discovery of silicates composed solely of quartz has been detected in such an environment. This discovery was made possible by the planet's very short orbital period. This facilitated the study of transmission spectrography, a technique that measures how starlight is scattered and filtered as it passes through the atmosphere of an exoplanet. This exoplanet, with its increasingly incredible properties, has been the subject of another discovery, just as improbable as ever. Using high-resolution spectroscopy, a new team of scientists reported in August 2023 that they had detected another molecule in the atmosphere of WASP-17b. This is the first time that such a molecule, usually detected in stars, has been found in a planetary atmosphere. The molecule in question is chromium hydride, a metallic chemical compound nicknamed the thermometer molecule. This extremely rare metal hydride is singularly abundant in a temperature range between 930 and 1730 degrees Celsius, or 1700 and 3150 degrees Fahrenheit. Through these discoveries, scientists hope to gain further insight into the formation and evolution of this planet, but also of others. Now that they know that such molecules can be found in the atmospheres of similar objects, they will be able to focus their research even more precisely. It's a valuable opportunity for them to deepen their understanding of exoplanets and the processes that govern their atmosphere, formation, and evolution. Let's move on to another Jupiter-like gas giant and find out why this one intrigues astrophysicists so much. Named HD 106906b, this exoplanet, 11 times more massive than Jupiter, was detected around 336 light-years from our Sun in the Southern Cross constellation. This exoplanet stands out for its very strange orbital properties, and with good reason. It takes almost 15,000 years to complete one revolution around its host star, a pair of stars made up of two F-type yellow-white dwarfs. When its discovery was announced in 2013, scientists declared it a great first. No other planet has ever been detected so far from its central star, its distance having been estimated at over 730 astronomical units, or practically 68 billion kilometers, or 42 billion miles. To calculate this orbit, astronomers were able to draw on 14 years of data collected by the Hubble Space Telescope. This extraordinarily precise data enabled scientists to prove the unusual motion of a gas giant. It moves with unprecedented slowness due to the weak gravitational attraction between it and its host stars. Even more surprising, this exoplanet follows a relatively elongated orbit, but more importantly is located outside the debris disks surrounding its parent star, unlike most exosolar planets of the same type. What's more, this disk appears to be undergoing significant gravitational interactions and is also showing itself in a particularly unusual shape, not circular, but stretched and asymmetrical. The question now is how such a planet could have ended up so far from its main star, and what's more, outside the disk. Astrophysicists initially suggested that the planet had indeed formed inside the debris disk, but that the strong gravitational interactions had then ejected it into interstellar space. A nearby star would in turn have allowed this gas giant to stabilize its atypical orbit, preventing it from drifting forever into the cosmos. However, this theory has been called into question by other researchers who have developed a model to track the orbital trajectory of HD 106906b, and above all, to determine its impact on the debris disk. While no other planets have been detected in this planetary system, the orbit of the one studied alone is sufficient to explain the shape of the disk. What's more, this new study calls into question where this exoplanet formed. According to the scientists, the model shows that it probably formed not inside, but outside the disk. If this were not the case, and still according to their model, the shape of the disk would be very different from what we can observe today. Still, the enigma remains unsolved. Could it be that neighboring stars have destabilized the planet during their migration, causing the planet in turn to disrupt the disk? Conversely, could the host stars of this binary system have caused disturbances to the planet, subsequently distorting the disk? Or could neighboring stars during a close passage have simultaneously disturbed the planet and the disk? I'd now like to take you to the constellation of Centauri, where you'll be in for another surprise. Located 430 light-years from Earth, an orange-colored star in the pre-main sequence, whose mass and size are similar to those of the Sun, has a most extravagant planet as its companion. Meet J1407b and its celestial jewels, spread out like no other in this starry cosmos, discovered in 2012. As you can see, it boasts dozens of rings, whose impressive size is enough to make our beautiful Saturn swoon, their diameter reaching 120 million kilometers, or 75 million miles. In comparison, Saturn's rings are 200 times larger, equivalent to the surface of several full moons in our night sky. According to astronomers, there appear to be more than 30 of them, each harboring innumerable grains of cosmic dust, and perhaps even good-sized lumps of matter. Once again, this astonishing discovery was made by chance. During an exoplanet search program, the star of this planetary system attracted attention for its behavior. During nearly 2 months of observation, its light curve showed particularly anarchic and rapid fluctuations, ranging from a few tens of minutes to several hours. Faced with this phenomenon, only one explanation emerged. The star is eclipsed by a system of rings, the latter displaying a wide range of dimensions. What kind of exoplanet could possibly have such attributes? It's probably a super Saturn in its infancy. The rings contain a lot of matter in the form of dust, which is likely to gradually coalesce into satellites orbiting the planet. In fact, one of these hypothetical satellites is probably in the process of forming, as evidenced by the existence of a gap within this enormous structure. This apparent gap between two disks can plausibly be explained by the formation of a satellite in this portion, which has agglomerated most of the matter present here. According to their estimates, this exoloon could have a mass somewhere between that of the Earth and Mars, and would take 2 years to complete a full revolution around J1407b. For astrophysicists, this process is only just beginning. In several million years' time, after having thinned considerably, these rings will eventually disappear forever, leaving in their place several satellites orbiting this super Saturn. But for now, we can still enjoy the grandiose spectacle offered by these gigantic rings. Our journey now takes us close to an exoplanet that seems to rival most stars. We'll take a step back, as its temperatures are extremely hot. In fact, it's hotter than at least 80% of the stars in our universe. Back in the Cygnus constellation, 650 light-years from Earth, here's Kelt 9b. Discovered in 2017, this strange planet with an atmosphere unlike any other is the hottest ever detected. An ultra-hot Jupiter, it orbits its star, itself known for its more than strange properties. Almost twice the size of the Sun, this star is also one of the hottest known to date. You're looking at one of the most extraordinary duos in the universe. This host star reaches insane temperatures, approaching 9,900 degrees Celsius or 18,000 degrees Fahrenheit. As a reminder, our Sun, whose fiery rays are already enough to wreak havoc, doesn't exceed 5,500 degrees Celsius or 10,000 degrees Fahrenheit in surface temperature. But that's not all. This blue giant star rotates so fast that its appearance is distorted, with flattened poles and a singularly enlarged equatorial zone. In fact, its flattened spheroidal shape has repercussions for its companion planet. Although Kelt 9b experiences unprecedented temperatures, being some 30 times closer to its star than the Earth is to the Sun, it does have seasons. Take a look at this magnificent gas giant. Almost twice as large as Jupiter, its mass is estimated at almost 3 Jovian masses. Exceptionally close to its host star, it receives 44,000 times more energy than we do from the Sun. As you can see, this colossal exoplanet orbits rapidly. Its complete revolution takes just 36 hours. Rather short for a year, isn't it? Its orbit follows a trajectory that passes just above the star's 2 poles. So when Kelt 9b is near one of them, it passes through an extremely hot zone. But when it faces the star's swollen equator, it benefits from a certain cooling. This strange planet thus experiences 2 warm seasons and 2 winter seasons, so to speak, at regular intervals every 36 hours. On the other hand, due to its proximity to the star, the planet is locked onto the latter's gravitational tides, immutably showing the same face to this blazing sun. If Kelt 9b hadn't been so massive, its atmosphere would have evaporated long ago under the effect of the ultraviolet radiation produced by the star. Like Mercury, it would already resemble a small rocky desert core. Nevertheless, this scenario could well unfold at any moment. For the time being, however, its vaporous envelope is undergoing the wrath of this unusual star. Kelt 9b's atmosphere is continuously plowed by its parent star, to the point where it resembles no other planetary atmosphere, as attested by a study published in 2018 in the journal Nature. The abundant hydrogen molecules are literally torn apart when exposed to the star's fierce forces. Then, when they reach the planet's dark side, they recompose. Then, when they again come into contact with the star's light, the process starts all over again. Analysis of this atmosphere has also enabled scientists to detect iron and titanium atoms, which cannot combine with other atoms due to the intense heat. Kelt 9b is therefore one of the first planets to detect iron in its atomic form. Iron, though abundant in the universe, is usually combined with other molecules when identified in the vicinity of any solid cosmic form. Once again, this atypical planet is a formidable field of exploration for astrophysicists. Future observations will enable us to study in greater detail the boundary that separates the two sides of this exoplanet. And who knows, could water molecules be present? When we think of luminous objects in the night sky, we usually think of the many stars. However, all kinds of celestial bodies are also capable of shining. Such is the case of an exoplanet discovered in 2020 by NASA's TESS satellite. This is LTT 9779b, the brightest exoplanet ever detected by astronomers outside our solar system, with a brilliance similar to that of Venus. Located more than 260 years from our Sun in the constellation of the Sculptor, this exoplanet is of the hot Neptune type. Its radius is around 5 times that of the Earth, while its mass is 29 times greater. With an orbital period of just 17 hours, it is one of the few planets recorded in the hot Neptune desert. Given its proximity to its host star, it's no surprise that scientists have recorded extremely high surface temperatures, reaching over 2,000 degrees Celsius or 3,600 degrees Fahrenheit on its illuminated side. Astrophysicists have estimated that this strange planet is able to reflect 80% of the light emitted by its host star. But how is this planet able to behave like a reflecting mirror, and precisely in this configuration? Because of the extreme heat, no clouds are expected to form on the surface of such an object. And yet, it would seem that clouds are the reason LTT 9779b looks the way it does. Until now, only gas giants 10 times larger than our Earth, or modest rocky planets half their size, have been detected with orbits of less than 24 hours. But this exoplanet is about 5 times the size of our Earth. Its existence alone is already a mystery. What's more, given its proximity to its host star, any trace of atmosphere seems unthinkable. The latter should have been torn off long ago. For scientists, there is only one possible explanation. The planet's atmosphere is saturated with silicate vapors, the material found in glass, and metal vapors vaporized by the intense heat. In short, metallic clouds envelop the planet. Like a shield, they are incredibly reflective, giving it an extraordinary mirror-like appearance and preserving its atmosphere. The detection of such a planet represents a major breakthrough for the scientific community. In particular, it provides proof that an object the size of Neptune can survive in such an unseemly environment. But what happens when the star of a planetary system dies? What happens to the planets as their host star declines to the white dwarf stage? While the inner planets are probably absorbed during the red giant phase, do the outer gas giant planets manage to survive? This question is far from trivial, for what will become of our own planetary system when our sun reaches this stage? A team of astronomers recently found the answer. After pointing the sensors of the James Webb Space Telescope at various white dwarfs, the scientists succeeded in detecting two massive exoplanets. Each of these two planets orbits a dead star, both at distances similar to those of the gas giants in our solar system. These two exoplanets, named WD 1202-232 and WD 2105-82, have masses estimated at 1 and 7 times that of Jupiter. Respectively, 5.3 and 1.6 billion years old, these gas giants orbit at 11.5 AU for the former and 34.6 AU for the latter. This configuration is ideal for scientists. The two exoplanets bear a striking resemblance to Jupiter and Saturn respectively. What's more, our Sun in a few billion years' time should resemble this white dwarf. Better than divination, this discovery is capable of showing us what our own system will probably look like when the time comes for our Sun to slumber for eternity. Before turning into a white dwarf, our star will most likely annihilate the planets in its inner system, including our beautiful Earth. On the other hand, gas giants like these two exoplanets are likely to survive the cosmic upheaval. Our journey is coming to an end. We're about to return to terra firma, topped by a more forgiving sky where the weather, though sometimes capricious and devastating, remains most clement. Through the worlds we've just visited, each more fascinating and intriguing than the last, you've been able to observe the diversity and richness of the universe that surrounds us. While the cosmos abounds in systems with extraordinary properties, few are thoughtful enough to support any form of life. However, one recently discovered exoplanet, located just 137 light-years away, is proving to be very promising. This is the exoplanet TOI 715b, whose discovery was announced in January 2024 by NASA. This super-Earth evolves in the so-called conservative habitable zone around its star, a red dwarf, alongside a second, even larger planet, whose existence has yet to be confirmed. While the presence of liquid water on its surface is conceivable, thanks to ideal temperatures, the other criteria essential for life are still being studied. This exoplanet, which receives the equivalent of 86% of the light we receive from the Sun, could well be covered with oceans and continents. Clouds similar to our own are also conceivable. Of course, no one can say whether it is actually habitable, or whether it already harbors even a single form of life. But this possibility is a beacon of hope, driving researchers ever onward to explore the cosmos. Who knows what the future holds? Perhaps one day we'll be able to make contact with other civilizations from an unknown world. And why not finally tread the soil of extraordinary exoplanets? Let's continue our journey back in time with some of Curiosity's most memorable discoveries. The rover has made its contribution to a great mystery hovering around the red planet and intriguing scientists. Is there or is there not methane on Mars? In recent years, some observations have reported the presence of methane on Mars, others not. So, true or false? And why does the presence of methane intrigue scientists? Curiosity has detected methane particles at least 6 times in the atmosphere of Mars. Very small quantities of methane, like a pinch of salt in an Olympic-sized swimming pool. Logically, scientists suspected that Curiosity itself was producing the methane it detected. But no, the analyses were conclusive. The methane did indeed come from Mars, a conclusion that astonished scientists. Firstly, because it contradicts the observations of the European ExoMars Trace Gas Orbiter mission, which detected no methane on Mars. But also because on Earth, 95% of methane is produced by living organisms, notably the microbes that help animals digest. So yes, it's true that a small proportion of terrestrial methane comes from the Earth's geological activity. For example, in oceanic ridges, liquid seawater comes into contact with rocks, called peridotites. This contact triggers a serpentinization reaction, releasing methane. Most of this methane is stored at the bottom of the oceans, but a small amount ends up in our planet's atmosphere. Yes, but whatever the process behind methane production, scientists had no idea that it would be found on Mars. After all, to date, no living organisms or liquid water have been detected on Mars. So where does Martian methane come from? But there's another mystery linked to this methane. It's a stable molecule with a life expectancy of 300 years on Mars. Logically, methane should therefore accumulate in its atmosphere. But this is not what scientists have observed. Observations show otherwise. Methane concentrations on Mars fluctuate and are not uniformly distributed. What's more, once measured, they are no longer found in the atmosphere. Researchers have finally found a possible explanation for this mystery. Curiosity's observations were mainly made at night, because its instrument, the TLS, is so power-hungry that it can only function when the other equipment is switched off. It would seem, then, that methane is only present on Mars at night. How is this possible? At night, methane would ooze out of the ground. During the day, it would be stirred up in the atmosphere and diluted to quantities that can no longer be detected by our instruments. The second mystery linked to Martian methane is why it doesn't accumulate in the planet's atmosphere, even though it has a lifespan of 300 years. Something is destroying the methane, but we don't yet know exactly what. Electrical discharges caused by Martian dust? The impact of abundant surface oxygen? The final mystery to be solved is that of the origin of this Martian methane. Several hypotheses have been put forward. Active volcanism? Comet impact? Methane-producing microorganisms present in the depths of the red planet, where the temperature would allow liquid water to be maintained? The hypothesis of active volcanism on Mars has its adherents, especially since Curiosity made another headline-grabbing discovery in 2015, a rare mineral that bears witness to potential volcanic activity. This mineral, extremely rare on Earth, is tridymite. It forms when silica-rich lava reaches high temperatures and comes into contact with water. At first glance, this seems impossible on Mars, where no trace of liquid water has yet been found. Scientists have looked into this puzzle and come up with a possible explanation. There may be a magma chamber beneath Gale Crater. The magma gradually cooled over time, Silica-rich minerals would have developed in this magma chamber, and during a volcanic eruption, would have been ejected. The wind would have moved them and brought them into contact with the water of the lake in Gale Crater. Thus, tridymite could have formed by crystallization, theoretically anyway. After all, no one suspected that the formation of tridymite, an extremely rare mineral on Earth, could occur on Mars. It would seem, then, that Mars was once the scene of far more violent volcanic activity than we might have thought. The Curiosity rover was responsible for another important discovery in 2016. The discovery on Mars of a chemical element found on Earth in arid zones where a lot of water has evaporated, boron. As part of its mission, NASA's robot surveys the slopes of Mount Sharp, analyzing the sedimentary layers every 25 meters or 82 feet. One of the samples taken revealed the presence of several elements, such as sulfur, nitrogen, oxygen, phosphorus or carbon, but also boron. All these elements are useful for nourishing microbial life. As for boron, it is used to stabilize the sugars used to manufacture RNA, a nucleic acid present in virtually all living beings and in some viruses. It could be that in this crater, which was once home to water. Is it possible that a form of life developed billions of years ago? But even if all the conditions were met, that doesn't mean that there was microbial life on Mars at that very spot. We're still missing the proof. Over the years, Curiosity's observations have considerably advanced our understanding of the Red Planet. But they have also been invaluable to science in the broadest sense of the word. For example, during its many journeys over the hills of Mars, the rover noticed that rocks prevented ionizing rays from reaching it. Could these rocks replace the magnetosphere that our neighboring planet lacks? This information could prove invaluable when it comes to preparing future astronaut voyages to the Red Planet. Curiosity's mission is scheduled to last until September 2025, and perhaps even until 2030. Between now and the end of its mission, the rover will be studying a region it has not yet traversed, whose soil is mainly composed of sulfates. These analyses should tell us more about the climatic transition that led to the aridity seen on Mars today. Since February 2021, Curiosity is no longer alone in its mission. It is now working with another NASA rover, Perseverance. Let's take a closer look at this astromobile. February 18th, 2021. The Perseverance rover has just landed on Mars in the Jezero crater, accompanied by its colleague, the Ingenuity drone. These two robots are here for one reason: to complete the Mars 2020 mission. A mission estimated at $2.5 billion, and in which scientists have high expectations. What exactly does this mission involve? The idea is to collect samples from the soil of the Red Planet and bring them back to Earth. These samples will be used primarily to better understand our neighbor's geological past and perhaps find traces of microbial life, either in the present or in the past. And why not? Mars once had a denser atmosphere and rich water resources, a bit like Earth. Experts don't believe that Mars was home to intelligent life. Instead, we're looking for traces of primitive microlife. Thanks to Perseverance, NASA now has 2 active rovers on Mars. One of the rover's instruments is the SuperCam. It is, in a way, the rover's eye. The SuperCam consists of spectrometers, a camera, and a microphone. Perseverance is also equipped with a drill, enabling it to excavate the soil of Mars. With all this, the rover is well equipped. The samples collected by Perseverance will be analyzed on their return to Earth. In the meantime, they are sealed in tubes and stored by the rover, which is perfectly autonomous in its mission. If Perseverance collects samples that prove the existence of life on Mars, we'll have to wait until it returns to Earth to find out. In any case, it will be a first. Never before have samples been brought back from space to be analyzed on Earth for possible traces of life. The rover was also sent to Mars to test technologies for potential Martian colonization. For example, it tested a method for producing oxygen from the Martian atmosphere. On April 20th, 2021, 5.4 grams of oxygen were produced from carbon dioxide, enough breathable air for 10 minutes. Perseverance will also analyze local weather conditions to determine what might affect astronauts on a mission to Mars. These missions look promising, especially as the Jezero crater is an interesting sight. This 49-kilometer, 30-mile diameter impact structure is home to a delta that is thought to have formed where water once flowed into a lake. The area must therefore once have been rich in liquid water. Experts have estimated that around 3.5 billion years ago, the Jezero crater was home to a vast Martian lake, 250 meters or 820 feet deep. Perseverance didn't land on Mars alone. A helicopter drone called Ingenuity accompanied it on its mission. But what is the purpose of this helicopter weighing just 1.8 kilograms or 4 pounds, which carries no instruments apart from cameras? Ingenuity is a true pioneer. It is the first helicopter drone in history to be deployed on a celestial body other than Earth. It was sent to Mars as a test. Flying a helicopter on the red planet remains a challenge. It has to be able to climb into Mars' atmosphere on its own, where atmospheric pressure is much lower than on Earth. But there are other challenges too. The cold, autonomy. But on April 19, 2021, Ingenuity brilliantly rose to the challenge with its first successful hover flight. Since the start of their mission, Perseverance and Ingenuity have exceeded scientists' expectations. A few weeks after its arrival on Mars, the researchers switched on the rover's microphones. We were able to discover the sounds of Mars. In June 2021, the rover left its landing site to begin drilling operations in search of biosignatures. These biosignatures can be, for example, traces of mineral salts or organic matter. The idea is to prove that microbial life did indeed exist on Mars when the planet was still home to liquid water. After an initial failed drilling, a second attempt was made in September and was successful. A mechanism was then put in place. Ingenuity acts as a scout for the rover, which continues to drill. In January 2022, the Perseverance arm was blocked for several days by rocks. But the rover lives up to its name. The little routine set up by the two robotic colleagues continued. While the rovers continue their mission on Mars, NASA and ESA researchers are already planning the next missions, starting with the one that will return the samples to Earth, probably in 2026. In concrete terms, how do the researchers plan to recover the Perseverance samples? The idea is to send two vehicles to Mars, a rover to retrieve the tubes, and a rocket equipped with a container. The rocket would take off from the Martian surface and place the container in orbit around Mars. The Earth Return Orbiter (ERO) spacecraft will retrieve the container and return it to Earth. If all goes well, the samples collected by Perseverance could be back on Earth in 2031. A third rover is currently on Mars, with missions similar to those of Curiosity and Perseverance. The Chinese rover, Zhurong, arriving on the Red Planet on May 14, 2021, shortly after Perseverance, it will be the first Chinese rover to set foot on Mars. Until now, only NASA has been able to send these rovers to the Red Planet. Like Curiosity and Perseverance, Zhurong aims to find hypothetical traces of mineral salts and organic matter. Put into hibernation in the spring of 2022, the Chinese rover was due to wake up in December 2022, when Martian temperatures had risen again. But recent images show that it is still stationary on the Red Planet's surface, and its solar panels are gradually being covered with dust. Fortunately, Chinese scientists have plenty of data to work with until the rover wakes up. And it looks like the rover had time to make a major discovery before it went into hibernation. Zhurong has discovered traces of liquid water in Martian sand dunes formed only a few 100,000 years ago. These dunes are located where the rover landed on May 15, 2021, in the southern part of Utopia Planitia. The data collected by Zhurong is astonishing. The surface of these dunes is crusted and dotted with cracks and other traces that are usually formed by interactions with fluids. But that's not all. The composition of the dune's surface is rich in elements such as hydrated sulfates, opal, Ct, iron oxides, and chlorides. A chemical signature typical of reactions with liquid water. Reactions that would have occurred relatively recently, since the dunes are only 1.4 to 0.4 million years old. These observations are unprecedented. There could have been liquid water on Mars in the very recent past, although nowhere near the quantities found in the ancient lakes of the Gale and Jezero craters. The researchers believe that this liquid water could be the result of the transfer of water vapor from the polar caps to the equator during periods of cooling in Mars' lower latitudes. In other words, this region would have repeatedly presented more favorable temperatures than the rest of Mars, with moisture conducive to life. From the USA to China and Europe, international space agencies are sending increasingly sophisticated equipment to Mars. But clues are also arriving directly from Mars to Earth, such as the Black Beauty meteorite. In 2011, mysterious fragments of an unknown rock that crashed to Earth billions of years ago were discovered in Morocco's Western Sahara Desert. This mysterious black rock has been dubbed Black Beauty. Its real name is more complicated: Northwest Africa 7034, or NWA 7034. Scientists took numerous samples of this rock and concluded that it came from our neighboring planet. Black Beauty was therefore composed of 4.5 billion-year-old Martian rock, a true gift from heaven. After further research, it was finally estimated that this rock was formed during the very beginnings of the solar system, when the Martian and terrestrial crusts were not yet complete. We were also able to identify the crater of origin of this mysterious rock from among nearly 80,000 candidate impact craters. This crater, located in the southern hemisphere of the red planet, has been named the Karatha crater. But how did Black Beauty land on Earth? It's between 5 and 10 million years ago. An asteroid collides with Mars, creating the Karatha crater. Fragments of Martian crust are ejected into space. Among them, Black Beauty, ejected at a speed of 5 kilometers per second, or 3 miles per second. The rock travels through space for 5 to 10 million years, ending up on Earth. The study of Black Beauty is crucial. This rock contains the oldest Martian fragments ever found, dating back 4.48 billion years. These fragments show astonishing similarities between the ancient crust of Mars and the continents of today's Earth. According to some researchers, Black Beauty even holds the secret to the first 10 million years of the history of Mars, and by extension, of all telluric planets, including Earth. On Earth, it's impossible to find rocks this old, as plate tectonics pull them back towards the core. This little rock, weighing just 320 grams, is invaluable for understanding the history of Mars, and we didn't even have to go and look for it on Mars. What's next? Scientists would like to send a probe to Mars to explore the area and exploit this lead that has literally fallen from the sky. The idea is to glean valuable information about the formation of rocky planets 4.5 billion years ago. And why not, at last, understand why until now no equivalent of our Earth has ever been found in the immensity of space? We've now reached our destination. Before you lies the planet Mars, the red planet, our neighbor in the solar system, yet one that still conceals so many secrets. Ever since the Perseverance rover and its colleague Ingenuity joined Curiosity on the surface of Mars, new discoveries have been consistently challenging what we know. Almost every month, new scientific publications reveal well-kept secrets about the red planet. Let's take a look at the latest discoveries on Mars. Let's start by going back in time 2 years. It's March 2022. A photo from the Curiosity rover catches the attention of scientists. It's a mineral, concretion, barely 1 centimeter or 0.3 inches wide, flower-shaped, and bearing an uncanny resemblance to our terrestrial sand roses. It has been named blackthorn salt. You'll understand why in a moment. As you can see from this photo, the concretion has several arms, which are connected at the base. This is hardly surprising, as it's not the first time such a formation has been photographed on Mars. In 2008, the Spirit rover photographed a whole series of such concretions in the Gusev crater, nicknamed cauliflowers. This time, however, scientists have turned their attention to the formation process of this Martian sand rose. It is thought to result from a rearrangement of minerals, a process associated with the presence of sulfate-saturated water. In a word, this concretion would be formed like our sand roses on Earth. Indeed, its appearance is reminiscent of an evaporitic concretion. Evaporates are sedimentary rocks like gypsum or rock salt, formed by crystallization in shallow basins subject to strong evaporation. They are found, for example, in lagoons and the Dead Sea. Terrestrial sand roses are nothing other than gypsum crystallizations in a sandy environment, such as the desert. Hence their magnificent orange color. They don't form in exactly the same way as Dead Sea gypsum, for example, but the process is similar. In an unconsolidated medium such as sand, gypsum crystals are soaked up by groundwater rich in calcium sulfate. As the water table evaporates, it becomes more concentrated in ions until saturation allows the minerals to crystallize. Gypsum crystals then grow, pushing aside the sand that surrounds them. This is why on Earth, sand roses are found buried under several meters of sand. The Martian concretion could be the result of the same type of process. Curiosity found it in the same type of soil, a sandy soil, but on the surface and not buried in the sand, certainly due to erosion by Martian winds. This discovery speaks volumes about the presence of water in the red planet soil. So there's probably water in the form of brine in the subsoil of Mars. And why blackthorn salt? Because this sand rose looks more like a blackthorn flower than a rose. Let's keep moving forward in time in search of the red planet's latest secrets. It's now May 4th, 2022. While Perseverance's mission has only just begun, that of NASA's InSight probe is nearing completion. Landed on Mars on November 26, 2018, it officially ended its mission in December 2022. InSight is equipped with a heat flow probe and a seismometer. Its objective? To analyze the geological development of Mars. The data collected by this NASA probe has enabled us to confirm that Earth and Mars are quite similar in terms of structures. With just a few differences, the red planet has a larger liquid core and a thinner crust than previously predicted. With just a few months to go before the end of its mission, the InSight probe has recorded the largest Martian earthquake ever recorded. In fact, it's the most powerful earthquake ever recorded on an alien planet. Or should we say, Marsquake? Because on the red planet, there are phenomena similar to our earthquakes, even if there are no tectonic plate movements. Since 2018, the InSight probe has been recording all these Martian tremors to study their causes. On May 4th, it hit the jackpot. InSight recorded a Martian tremor of magnitude 4.7 that lasted over 6 hours. Of the more than 1,300 tremors recorded by InSight, this was by far the biggest. What could be the cause of an earthquake of this magnitude if Mars has no plate tectonics? The most likely hypothesis is that a large meteorite hit the red planet. Using all the probes currently orbiting Mars, scientists have looked for traces of a possible collision, but nothing. If there had been such a collision, we'd have found dust flying into space. A new impact crater would have appeared on the surface of Mars, with an estimated diameter of 300 meters or 980 feet. But nothing has been found, so this is not a collision. The only possible explanation is that this magnitude 4.7 earthquake was caused by internal Mars activity. Because the cooling of the Martian crust is not homogeneous, this could generate stresses. These tensions could lead to greater mechanical stress releases than previously thought. Experts are still not 100% sure why these earthquakes occurred. All that is known is that the more we know about the formation of the Martian mantle, the magma currents at work on Mars, or the reason for the loss of Mars' magnetic field in the past, the better we'll be able to solve these mysteries. Let's move forward a little further in time. It's October 27, 2022. NASA announces the discovery of a gigantic meteorite impact crater on Mars, a first since we began observing the red planet. This meteorite impact, measuring 150 meters or 490 feet in diameter and 21 meters or 69 feet deep, has once again been discovered by the InSight probe. It is the largest meteorite crater ever discovered on a planet. Nearby, a second crater was discovered, 130 meters or 425 feet in diameter. NASA has reconstructed a sketch of the meteorite that would have caused such an impact. Its mass would have been between 250 and 650 tons, for a size of 5 to 12 meters, or 16 to 40 feet. The impact speed would have been 7.5 kilometers per second, or 4.6 miles per second. Impacts caused by this giant meteorite date back to December 24, 2021. At that time, the InSight probe recorded a magnitude 4 earthquake on the surface of the red planet. The tremors caused by the impact are said to have thrown up boulder-sized chunks of ice, which you can see in white in the photo released by NASA. It's fascinating enough to have observed this phenomenon, as such collisions haven't occurred on Earth for centuries. But it's also fascinating to have been able to find an impact of this size. The impact caused blocks of ice to emerge, ice which lies beneath the Martian surface. Ice means liquid water. Liquid water means potential life, but also resources for a future human settlement on Mars. This is not the first time that ice has been discovered on Mars, although it is true that it is unusual to find it in a region so close to the Martian equator. In 2018, the Mars Reconnaissance Orbiter observed ice on Mars in 8 locations. As you can see from the photo released at the time, the ice was distributed in superimposed layers just a few meters below the surface of Mars and up to several tens of meters deep. And this on the side of 8 Martian cliffs in the red planet's northern and southern hemispheres at latitudes between 55 and 58 degrees. A discovery that caused a sensation in the scientific world, even though it was already known that there was icy water on Mars. As early as the 1780s, British astronomer William Herschel was already observing variations in the size of the polar ice caps over the seasons. In 2004, the European Mars Express probe confirmed the presence of ice, as did samples brought back by the Phoenix lander in 2008. But that was at a latitude of 68 degrees, close to the Martian North Pole, and not so close to the equator as in 2018 or 2022. In any case, all these observations of icy water have confirmed that Mars is a frozen planet. It is covered with permanently frozen ground at the equator and superficially beyond 45 degrees latitude. The temperature on the surface of Mars is almost always negative, dropping as low as minus 140 degrees Celsius or minus 220 degrees Fahrenheit in winter. On the other hand, it's possible for a sunlit surface to cross the threshold of 0 degrees Celsius or 32 degrees Fahrenheit, and as much as 20 degrees Celsius or 68 degrees Fahrenheit in summer at the equator in broad daylight. When this happens, the ice doesn't melt, it sublimates. In other words, water changes from a solid to a gaseous state. Water cannot exist in a liquid state on a planet with such a tenuous atmosphere. We have the very example of this on Earth. At the summit of Mount Everest, where atmospheric pressure is lower, water boils at a lower temperature, 60 degrees Celsius or 140 degrees Fahrenheit, instead of 100 degrees Celsius or 212 degrees Fahrenheit. And even then, the atmospheric pressure at the top of Everest is 34 kilopascal. Imagine on a planet like Mars where pressure varies between 0.03 kilopascal and 1.15 kilopascal. But how did these layers of ice form on the Martian mountainsides discovered in 2018? According to the researchers, it wasn't liquid water that trickled down and then froze. Given the conditions on Mars, this hypothesis seems unlikely. What is possible, however, is that they are wind-driven snowdrifts or condensation deposits. These deposits have formed periodically, following the oscillation of Mars' rotational axis, whose inclination varies more slowly, but with greater amplitude than on Earth. All that remains is to take samples from this area to find out more about what has caused these successive layers of barely buried ice. The discovery of ice on Mars also holds promise for future manned missions. Astronauts who one day land on Mars will need to extract water from the Martian subsoil in order to store and drink it. This water could also be used in gaseous form to manufacture oxygen and to supply rockets with fuel, thanks to the methane extracted. December 12, 2022. NASA photographs a strange geological shape on the surface of Mars. A shape that looks strangely like a bear's head. A bear's head on Mars immediately amuses scientists and the general public alike. Look closely. In the photo, you can see a hill with a collapsed V-shaped structure, representing the bear's nose, two craters forming the eyes, and a circular pattern, the bear's head. As you can imagine, this circular pattern has nothing to do with a bear. Rather, it's due to the covering of a crater by a deposit of mud or lava. In fact, it's nothing less than a crater, located 251 kilometers or 155 miles above the Terra Serenum region in the southern hemisphere of Mars. It's not a revolutionary discovery, but it's one that's gone viral. This unusual photo, released by the University of Arizona, has gone viral, particularly on Twitter, where it was relayed by the account dedicated to the Mars Reconnaissance Orbiter satellite. It was, in fact, the MRO satellite that captured this image with its high-rise onboard camera. This camera is said to be so powerful that it could photograph a kitchen table from space. This picture of the Martian bear isn't the first to have caused a stir because of its unusual appearance. Regularly, images released by NASA reveal recognizable shapes. A Perseverance shot released in April 2021 had already caused a stir. It showed the silhouette of a man lying on a rock in the middle of the sand on Mars sunbathing. An American UFOologist even tried to prove that it was indeed a man who had been photographed, and that this was 100% proof of intelligent life. The UFOologist went so far as to point out footprints behind the man, leading to the spot where he had been lying down. This phenomenon, which causes our brains to see recognizable shapes, such as faces or animals where none exist, has a name: pareidolia. It's the same phenomenon that occurs when you look up at the sky and see shapes in the clouds. In the case of the man lying on a rock, as in the case of the bear's head, it was indeed pareidolia, proof that sometimes observing things from our human perspective can get in the way of correctly interpreting what we see. February 8, 2023. NASA announces that it has discovered what it calls the best evidence yet of the existence of lakes on Mars. Let's take a step back in time. Today, Mars is a desolate, arid and dried up world swept by dust storms. A world even more hostile than terrestrial deserts. Temperatures on the red planet rarely exceed 0 degrees Celsius or 32 degrees Fahrenheit, and can even reach minus 140 degrees Celsius or minus 220 degrees Fahrenheit in winter and at night. Atmospheric pressure is very low, averaging 6 hectopascals. Obviously, there is no liquid water on the surface of Mars, but Mars wasn't always such a barren planet. In the 1970s, the Mariner and Viking probes revealed enormous flow channels on the red planet, and veritable canyons that were most likely dug by liquid water billions of years ago. These findings have been confirmed by recent Mars missions. There may even have been large lakes on Mars, as on Earth, which have now dried up. If water flowed on Mars in the distant past, it's because its atmosphere must have been denser than today, and its temperatures higher. Researchers believe that shortly after its formation, 4.5 billion years ago, Mars was very similar to Earth. What they are now trying to discover is why the Martian climate changed so drastically. How did Mars lose its atmosphere? And above all, what has become of the enormous quantities of water that once flowed over the red planet? At present, Mars' thin atmosphere is 95% carbon dioxide and therefore contains only minute quantities of water. Some of this water vapor condenses as ice on the surface of Mars, particularly towards the North Pole, where it forms a permanent ice cap. Thin clouds of ice can also be seen in Mars' atmosphere, again in the northern hemisphere. But all this is just a tiny fraction of the water that once existed on Mars. Considerable quantities must have escaped over time, escaping Mars' gravitational pull. Researchers believe that the remaining water is found in the Martian crust in the form of permafrost. In other words, there is a permanent layer of frost in the Martian crust. But all this doesn't mean that Mars has been inactive and frozen for all these years. There have been resurgences of water, as evidenced by the numerous marks found by probes orbiting Mars. Scientists explain this by the warming episodes induced by the steep inclination of the Martian polar axis. These warming episodes would have allowed the permafrost to partially melt, particularly at high latitudes. During these periods, atmospheric pressure and the greenhouse effect would have increased, temporarily enabling the resurgence of liquid water on the red planet's surface. This scenario is constantly being confirmed by discoveries of traces of liquid water on the arid, rocky surface of Mars. The latest. On February 8, 2023, NASA discovered traces of water waves on the surface of Mars. A major discovery that could provide proof of the existence of a lake on the red planet. This time, it's the Curiosity rover that has discovered these indisputable traces of the presence of liquid water on Mars in the past. Curiosity found rocks whose surface is marked by undulations, potentially linked to waves. Since its arrival on Mars, the rover has been climbing the slopes of Mount Sharp in search of clues to the planet's past. It was at around 800 meters or 2,600 feet above ground level in an area nicknamed the Marker Band that it photographed these undulating rocks, which have been miraculously preserved. An astonishing discovery in a region of Mars that scientists expected to be drier. For the researchers, this is not only the best evidence of a Martian lake ever found to date, but also a major clue to the complexity of the climate on Mars. These stones show that the transformation of Mars from a wet planet to a dry, cold one was highly complex. A discovery that shows us that, like Earth, Mars was also a beautiful planet with a complex climate and weather patterns. The wavy stones have not yet been analyzed. Curiosity was unable to extract any samples due to their hardness. But the researchers are not discouraged. They now hope to find new, softer, corrugated rocks that can be analyzed and reveal their secrets. Perseverance also recently discovered an ancient lake, this time in the Jezero crater, where it has been since landing on Mars. Between February 28th and March 9th, 2023, NASA's rover took a series of images that make us wonder. What if the red planet is home not to tranquil lakes, but to tumultuous rivers with currents, torrents, and waterfalls? This is what the Perseverance images suggest. Scientists believe that the Jezero crater, currently being explored by NASA's latest rover, may have been home to a tumultuous river. How did they come to this conclusion? It's thanks to the panorama taken by the rover's Mastcam Z instrument when it was in the former bed of this river. This could be one of the deepest rivers ever discovered on Mars. How do we know it was a tumultuous river? In fact, it's the size of the sediments lining the riverbed that indicates the strength of the current. The larger and heavier the pieces, the more turbulent the river had to be to move them. But that's not all. The Perseverance images show something else. We can see large curved strata, which show that the current was powerful there. However, scientists don't know exactly what the landscape looked like when a powerful river still flowed through the Jezero crater. Was the rock meandering, i.e. undulating across the landscape? Was it braided, with sandbars in the riverbed and small islands? Thousands of years of erosion prevent us from knowing precisely. But scientists are not giving up hope of one day being able to retrace the Martian landscape of thousands of years ago. Investigations will continue thanks to Perseverance, and researchers are confident of a positive outcome. That's why the Jezero crater was chosen as the landing site for Perseverance. From Mars' orbit, many clues suggesting that this depression had once been home to a lake. Perseverance quickly proved the existence of ancient deltaic deposits. A delta means liquid water. However, analysis of the magmatic rocks in the crater floor showed only very slight alteration by water. No trace of lacustrine sedimentation had been found either. In other words, it was unlikely that there had ever been a perennial lake in the crater. To explain the absence of lake sediments, researchers had come up with several possible explanations. The sediments had been buried under volcanic rocks, or they had been eroded by the wind, but more detailed observation of the rocks in certain parts of the crater showed that they had indeed been altered by a fluid, but in several stages. The lake hypothesis had therefore been ruled out. This was not a continuous alteration linked to static water. The details of these successive alterations remain unresolved, but the discovery was a promising one. So yes, we found traces of a tumultuous river in the Jezero crater, but no or very little evidence of H2 gas and iron, the essential energy source for microbial life on Earth. Rest assured, this doesn't mean that there were no organic molecules in the river. Maybe there were, but only sparsely. Or maybe they were using a different energy source as yet unidentified by scientists. August 9th, 2023. Mars research makes great strides forward with another major discovery, published in the famous journal Nature. A major discovery, since possible traces of life have been found on the red planet. The study was carried out by researchers from Toulouse and Lyon with the support of CNES, Canada, and the United States. These scientists have discovered fossil evidence of a cyclical climate on Mars, organized into dry and wet seasons, as on Earth. This discovery comes on top of Curiosity's discovery of simple organic molecules. In other words, we have here the ingredients for an environment conducive to the appearance of complex organic compounds, and hence life. As you can see, the surface of Mars is not made up like that of Earth. It is not renewed by plate tectonics. It has preserved vast terrains of fossil rivers and lakes, dating back billions of years. Curiosity has been exploring these remains since 2012. During its long mission on the red planet, the rover has been able to detect the presence of simple organic molecules that may have been formed by geological or biological processes. But for primitive life forms to emerge, favorable environmental conditions are required. Conditions must be right for simple organic molecules to organize themselves into complex organic compounds. This was the missing piece of the puzzle until the discovery announced on August 9th, 2023. Thanks to Curiosity, the research team discovered hexagonal salt deposits in sedimentary layers dating from 3.8 to 3.6 billion years ago. These patterns bear an uncanny resemblance to those found on Earth, in basins dried out during the hottest seasons. Could they be fossil evidence of a cyclical Martian climate like that on Earth? Researchers are convinced the climate on Mars could in the past have been organized into dry and wet seasons. But it's precisely this type of climate that allows molecules to interact. A regular cyclical climate. In this way, molecules can form complex compounds such as RNA, which are the precursors and building blocks of life. In other words, these are the first necessary steps in the synthesis of biological molecules, and thus of life. These conclusions have been verified in the laboratory. On Earth, there are no remnants of the natural processes at the origin of life. This discovery gives hope to researchers. Another planet may finally be the key to unlocking the mystery of life. A few months after this major discovery, it's the turn of the InSight mission to reveal more of the red planet's secrets. On October 26, 2023, another study was published in the journal Nature, once again challenging our knowledge of Mars. In September 2021, the InSight probe recorded a meteorite impact on Mars. The seismic data from this impact were then analyzed by the InSight mission team. The results of these analyses were published on October 26, 2023. The results of their study are like a paving stone in the pond. They propose nothing less than a new model for the interior of Mars. According to the proposed new model, the structure of Mars is made up of a core, followed by an inhomogeneous mantle composed of a layer of molten silicates. This model could explain all the geophysical observations made by the various Mars missions, but it could also provide a coherent explanation for the evolution of the red planet since its formation. How did scientists come up with this new model? In fact, they studied the propagation of waves generated by the September 2021 meteorite impact. And according to their findings, at the base of the Martian mantle is a layer of fused silicates. Starting from the outside, we would then have the following successive layers: the solid mantle, a thinner layer of partially melted silicates, the famous thicker layer of fused silicates, and finally, the red planet's metallic core. The new model also calls into question estimates of the size and density of the Martian core. According to the new data, the core would be 150 to 170 kilometers, or 100 miles smaller and 5 to 8% denser than previously estimated. It would contain fewer light elements than previously thought. Above all, such an internal structure means that the Martian core is isolated. As a result, it can no longer cool and generate a magnetic field like the one that existed on Mars during the first 500 to 800 million years of its evolution. What we have learned from this discovery is that Mars and Earth may have been similar at birth, but their internal evolution has been completely different. Researchers can't wait to find out more, and neither can we. At the end of 2023, a new discovery once again changed our idea of the planet Mars. Long considered a dead or inactive planet, Mars has nonetheless experienced recent volcanic activity. At least that's what a study published in December 2023 has revealed. Mars, like Earth, is known to have experienced intense volcanism. In fact, the largest volcano in the solar system is Olympus Mons, one of Mars' volcanoes. Olympus Mons is over 22 kilometers or 14 miles high. No structure on Earth can compare with such a geological monster, not even Everest, at 8.8 kilometers or 5.5 miles high. Above all, it's an indication that Mars is capable, or has been capable, of producing quantities of lava that Earth has never been able to produce, and over very long periods of time. Let's return to the discovery that was revealed in December 2023. It wasn't made in the Olympus Mons region, but in another equally impressive volcanic region of Mars, Elysium Planitia. This is the second largest volcanic region on Mars. Imagine a plain 3,000 kilometers or 1,900 miles in diameter, made up of piles of lava flows. In this quiet, desolate landscape, 4 major volcanoes rise up. Impressive in their size, these volcanoes are clearly extinct. That's why Mars has long been considered a dead planet. And yet, the discovery we're talking about has cast doubt. Mars may well have experienced major eruptions fairly recently. In 2022, a study revealed the presence of a giant mantle plume beneath the Elysium Planitia region, a sign of intense volcanic activity in the recent past. At the end of 2023, a new study confirmed these results and even specified the age of the last volcanic events in this Martian region. And the figure is staggering. Mars is thought to have experienced over 40 volcanic episodes in the last 120 million years. To give you an idea, this corresponds roughly to the time when dinosaurs reigned supreme on Earth. Each of these 40 volcanic eruptions produced huge volumes of lava that only Mars can produce. We're talking truly impressive volumes, up to 16,000 cubic kilometers of lava, or almost 4,000 cubic miles. This lava flowed through large fissures. The last of these 40 volcanic episodes would be no older than 1 million years, which on the scale of the chronology of the universe is very recent. At this stage, scientists are not ruling out the possibility of a volcanic awakening on Mars in the future. If Mars volcanoes were to erupt, what would that mean for us? Volcanic eruptions are capable of bringing large quantities of water to the surface. The magma itself contains a lot of water, which could be vaporized in the atmosphere and fall back to the planet's surface in the form of ice particles. And if there is ice trapped underground on Mars, as is probably the case, the arrival of magma in the Martian crust could melt it and create large sudden floods on the red planet's surface. Remember, finding water on Mars is crucial for 2 reasons: to find traces of life on the red planet, and to prepare for future manned missions to Mars. Let's turn first to Jupiter, the largest planet in our solar system, but also the one with the most moons. Jupiter is the 5th planet in the solar system in order of distance from the Sun, from which it is 779 million kilometers, or 485 million miles on average. This gas giant is the largest planet in size and mass, ahead of its neighbor Saturn. Its average radius is 69,911 kilometers, or 43,500 miles, or 11 times that of the Earth, and its mass is 318 times that of our planet. In fact, Jupiter is so huge that it has been visible to the naked eye since prehistoric times. After the Sun, Moon, and Venus, Jupiter is the 4th brightest object in our night sky. In fact, its great luminosity is the origin of its name, which comes from the Roman god Jupiter, master of the other gods. Composed mainly of hydrogen and helium, Jupiter's composition is similar to that of the Sun. Although it has a rocky core of heavy elements, it has no solid surface. In its atmosphere, several elements have been detected, including methane, ammonia, sulfur and nitrogen compounds, and water ice. Jupiter its 92 moons and rings are known as the Jovian system. But the giant planet's influence extends far beyond the Jovian system. This influence is exerted, for example, on Jupiter's Trojan asteroids, a group of asteroids that share its orbit around the Sun. The first space probe to fly over Jupiter was the American Pioneer 10 in 1973. Until 1979, the planet was explored by Pioneer and Voyager 1 probes. Then between 1995 and 2003, the Galileo probe orbited Jupiter, followed by the Juno orbiter in 2016. Juno is currently still orbiting Jupiter, until at least 2025. Unfortunately, we've long known that the chances of Jupiter harboring life are remote. Not only does Jupiter have no solid surface, but its presence and internal temperatures are extreme. No biological object could survive on this type of planet. So why do Jupiter exploration programs continue to fuel the hopes of alien hunters? Because Jupiter has 92 moons, 4 of which could potentially be habitable. These are the famous Galilean moons. That Jupiter's moons are habitable is hardly surprising. The Jovian system is often compared to a miniature version of the solar system. Jupiter accumulated so much thermal energy due to gravitational contraction during its formation that it now releases more thermal energy than it receives from the Sun. It could therefore act for its moons like the Sun for the planets in our solar system. Jupiter's 4 Galilean moons were discovered by Galileo in 1610. The Italian astronomer gave his name to these satellites, although they may have been observed earlier by the Chinese astronomer Gan Day in 362 BC. Between the end of the 19th century and the early 1650s, 8 other satellites of Jupiter were discovered: Amalthea, Himalaya, Elara, Pasiphae, Sinope, Lysithea, Carme, and Anakie. Leda and Themisto were discovered in the 1970s. So, before the arrival of space probes on Jupiter, 14 satellites of the Jovian system were already known. In 1979, 3 more moons were discovered. The number of known satellites was increased to 63 by new observations at the turn of the century. And from 2010 onwards, new observations expanded the catalog of Jovian moons. The last 15 known satellites were discovered very recently, in 2022 and 2023. So it's possible that more will be found in the years to come. It's true that at first glance, Jupiter's moons don't seem very hospitable. They are far from the Sun, almost all encased in ice, and their atmosphere is very sparse. But their observation has revealed some fascinating facts that are well worth investigating. Galilean moons are likely to conceal liquid oceans beneath their icy crusts, and liquid water means the development of biological organisms. What's more, the thick ice crust could provide good protection against radiation and meteorites, as well as thermal insulation conducive to the development of life, a bit like our atmosphere on Earth. But let's take a closer look at these moons to find out more about their potential for harboring life. Fasten your seatbelts as we explore Jupiter's 4 Galilean moons: Io, Europa, Ganymede, and Callisto. Let's start with Io, perhaps the moon in the Jovian system least likely to harbor extraterrestrial life. You'll soon see why. Io is also called Jupiter 1, perhaps because it is the satellite of Jupiter whose orbit is closest to the gas giant. Its period of revolution is just 42 hours. It is Jupiter's third largest moon and the fourth largest in the solar system. But it's also the densest and most geologically active, with over 400 active volcanoes. The fact that Io is so volcanically active first surprised scientists. When the Voyager probe flew over Io, it detected something unexpected on its surface: hundreds of giant active volcanoes. Other probes have since spotted huge lakes of molten lava. These discoveries are quite astonishing, as volcanic activity on Earth is fueled by the heat of the Earth's core. However, Io is so small that it must have cooled down completely billions of years ago. The only possible explanation was that Io certainly conceals in its core another source of energy that can continuously fuel this volcanic activity. The observation of volcanoes on Earth and the data collected on Io enabled us to imagine what life would be like on this moon. Living on Io would mean living in an extremely hostile environment, very cold or very hot, with no atmosphere. If you were to walk on Io, you would bounce slightly because the gravity on Io is the same as on the moon, 6 times less than on Earth. You could walk through black lava fields and witness phenomenal volcanic eruptions. Because on Io, eruptions are extremely spectacular. The gases released by the lava project clouds into the interstellar void. On its way to Pluto, NASA's New Horizons probe passed close to Jupiter in March 2007 and photographed an impressive volcanic eruption on Io. The eruption was that of the Tvashter volcano. The images taken at the time by the probe's high-resolution telescopic camera are impressive. They show a plume over 300 kilometers, or 185 miles high, rising in Io's northern hemisphere, and then raining down on the surface. These images provide researchers with proof that volcanic eruptions on Io are violent and powerful. But what could be generating so much energy in the heart of this frozen moon? In fact, this intense geological activity is the result of tidal heating. This heating is due to the friction generated inside the moon by its gravitational interactions with Jupiter and 2 other Galilean satellites, Europa and Ganymede, with which it is in orbital resonance. In other words, with each of its revolutions in its elliptical orbit around Jupiter, Io is buffeted by the gas giant's gravitational forces. When it reaches the point in its orbit closest to Jupiter, it undergoes a deformation of over 100 meters or 330 feet. Imagine this over billions of years, and you can see how intense friction could have arisen within this small moon. It's a bit like twisting and unfolding a piece of metal. It will eventually heat up. It's the same for Io. These movements and deformations have created an alternative energy source at the heart of Io, capable, in theory, of promoting life. Remember, life needs 3 elements to emerge, including a source of energy. With these discoveries, researchers realized that they had to stop believing that habitable celestial objects had to resemble the Earth in every way, and that habitable zones were necessarily dependent on the Sun. The perimeter likely to harbor life extended from the Earth to the farthest reaches of the solar system. However, the probability of life existing on Io remains very low. Yes, Io has an energy source. Yes, Io could contain the chemical elements that make up life, which would have been disseminated like on Earth by comets and asteroids billions of years ago. But researchers have never succeeded in finding the third element necessary for the emergence of life: liquid water or its equivalent. Why couldn't there be liquid water under Io's volcanic crust? Because, unlike other moons, Io is not made of water ice, but of silicate rock, surrounding a molten iron or pyrite core. Although the chances of Io harboring any form of life are slim to none, researchers are nonetheless interested in this moon for its intense volcanic activity. The interest of these volcanoes is not only scientific, but also aesthetic, as the images of this moon are magnificent. Io's volcanoes produce plumes of sulfur and sulfur dioxide, which, after rising several hundred meters, rain down and cover the moon's vast plains with a frosty layer of material. This material also forms a thin layer of atmosphere. Lava flows can extend over 500 kilometers or 310 miles in length. The moon's surface is constantly changing, taking on shades of yellow, red, green, white, and black. Io's surface is also dotted with over 100 mountains, the result of tectonic phenomena on the moon's silicate crust. Some of these mountains rise very high, even higher than Mount Everest, even though Io's radius is 3.5 times smaller than Earth's. Impressive, isn't it? There's no doubt that researchers won't be giving up their observations of this moon, which still conceals so many mysteries other than that of life. Let's continue our exploration of the Galilean moons with Europa, or Jupiter 2, the 6th closest moon to Jupiter. Europa has a period of revolution of 85 hours. With a diameter of 3,122 kilometers, or 1,900 miles, it's the smallest of the Galilean moons, but the 6th largest in our solar system. It's also the most interesting in the search for extraterrestrial life. In fact, according to researchers, it's the one where life is most likely to be found. Let's take a closer look at this mysterious moon. Europa has been flown over 12 times by NASA's unmanned spacecraft Galileo. Virtually all our data on Europa was collected by this probe. Europa is barely smaller than our moon. It consists mainly of silicate rock, with a crust of water ice and a core, probably of iron and nickel. It has a very thin atmosphere composed mainly of oxygen. Its temperature at the equator is minus 183 degrees Celsius or minus 297 degrees Fahrenheit, and its temperature at the poles can drop to minus 223 degrees Celsius or minus 370 degrees Fahrenheit. Unlike Io or our moon, its surface is free of craters, making Europa the smoothest surface celestial object in the solar system. Its surface is relatively young, estimated to be just 100 million years old. Locked in by Jupiter's tides, Europa rotates synchronously around the gas giant, so it always presents the same face. Small deviations in its rotation have been observed. All these observations could mean that there is a liquid layer between the surprisingly smooth surface of the small moon and its rocky core. This hypothesis was confirmed by the Galileo probe's studies of the satellite's interaction with Jupiter's magnetic field. While there are no impact craters on Europa's surface, there are glacial striations and fissures known as lineae. These crevices have been analyzed by the Galileo probe. The analyses show that in the past, the satellite's crust moved 80 degrees in relation to its interior, which would have been impossible without a liquid layer beneath the surface. What's more, as the Galileo probe got closer to Europa, it was able to observe these cracks more closely. The data collected suggests that in some places the ice cracked, then a trench formed, and a material filled the empty cracks and froze, allowing the parts to be welded back together. It's a bit like kintsugi. The probe also showed huge fields of jagged ice, as if the ice had melted and then roughly reconstituted itself, reminiscent of the ice that covers our oceans on Earth. The Galileo probe also took measurements of Europa's magnetic field. Analyses revealed the presence of an electric current that could correspond to that of a salty ocean of liquid water. According to the prevailing model, Europa's slightly eccentric orbit, maintained by its orbital resonance with Io and Ganymede, causes a tidal heating effect, allowing the ocean to remain liquid. This leads to a movement of ice, similar to plate tectonics, the first time this mechanism has been found anywhere other than on Earth. Like Io, Europa is therefore heated by internal friction due to its interaction with the gravitational fields of Jupiter and the satellites with which it is in orbital resonance. This may explain the jagged ice, which appears to have been melted and then refrozen. These interactions would cause powerful tidal waves in its inner ocean, further raising the temperatures inside the satellite. All this makes the presence of a liquid ocean possible. According to the researchers, this internal ocean could be as deep as 100 kilometers or 60 miles, with a volume twice that of our oceans on Earth, nicknamed the Blue Planet. Europa thus appears very different from its sister moon Io. It is covered by an exceptionally smooth and clean layer of ice. The highest features of its relief rise only a few hundred meters above the surface, a completely different landscape from Io's high mountains. The thickness of the ice crust varies between 10 and 30 kilometers, or 20 miles. Europa's surface is striated by a network of long, deep fissures. Some of these cracks may be reaching the groundwater layer. If this is the case, the ice that covers the bottom of the crevices provides valuable material for studying Europa's interior composition. Europa's geysers occur regularly throughout the moon's orbit, but are most frequent when the moon is furthest from Jupiter. This is because Jupiter's tidal forces are weaker when the moon is further away. These tidal forces are responsible for the formation of geysers, forcing water from the underground ocean towards the surface. These geysers, detected by the Hubble telescope, can reach up to 200 kilometers or 125 miles in height. These giant jets are made up of water vapor, a surprisingly clean form of water. It's possible that this water comes from Europa's underground ocean, or from giant lakes hidden beneath the ice crust. These are invaluable to scientists, as they would enable them to detect traces of life without having to use a lander. For the moment, nothing is certain. In the absence of concrete data, the composition of Europa's ice crust is currently estimated on the basis of one of its largest craters. Spectral analysis of the craters reveals compounds of magnesium, sulfur, iron, and hydrogen peroxide. Conclusion: there is certainly a wide diversity of minerals in the satellite's hidden hydrosphere. It's also important to point out that Europa's atmosphere contains oxygen, which is formed when icy water is broken down by UV rays. But Europa's gaseous envelope remains 1 trillion times sparser than that of the Earth. In any case, according to some calculations, the oxygen concentration in Europa's oceans could be sufficient to sustain single-cell aerobic life. Aerobicity is the ability of an organism or microorganism to thrive in ambient air using oxygen. Europa has liquid water and the building blocks of life. We still need a third element to affirm that life can develop there, a source of energy. And it does have a source of energy, undersea volcanoes that saturate the water with sulfur and iron oxides. Some researchers even claim that there could be multicellular organisms in the European Ocean, but this hypothesis is still premature. In any case, all we know is that we can't rule out the possibility of primitive life on this mysterious moon of Jupiter. Faced with all these possibilities, researchers are wondering whether it is really possible for a form of life to survive in this type of environment, namely, a cold liquid ocean enclosed beneath kilometers of ice, with no access to the sun's energy and with underwater volcanic activity as its sole source of power. The answer could lie on Earth. Biologist Tim Schenck has explored the waters of our planet that bear the closest resemblance to the icy depths of the Jovian satellite. 320 kilometers or 200 miles from the North Pole, the biologist sent robots 3,600 meters or 12,000 feet deep beneath the Arctic ice sheet, where sunlight never breaks through. In other words, the robots were sent into an ultra-hostile environment, where temperature and pressure levels are extreme due to underwater volcanic activity. The aim? To understand what might be going on beneath Europa's ocean by observing the most hostile underwater environments on our planet. At depths of 3,600 meters or 12,000 feet in the heart of the Arctic Ocean, Tim Schenck's robots, unsurprisingly, collected evidence of a very hostile environment. Volcanic fissures spew water at 370 degrees Celsius or 698 degrees Fahrenheit, saturated with toxic chemical compounds such as hydrogen sulfide. This type of fissure is more than likely to be found in the depths of Europa's oceans. Surprising as it may seem, Tim Schenck has discovered living organisms around these cracks. These cracks are in fact lined with microbes for miles around, new forms of life that we never knew existed, but which are indeed living organisms. Even the polar oceans on Earth harbor microbial life, so why not on Europa? How do these microbes survive in such a hostile environment? Instead of using the sun's energy, they use sulfur, methane, and hydrogen as a source of chemical energy. The next step is to land a probe on Europa to verify the scientists' theories. But for that, we'll have to wait a little longer. For one thing, the moon is 628 million kilometers away. What's more, we'd have to build a robot capable of crossing kilometers of ice, then swimming in the icy water to collect data. This is already a complex task on Earth, so imagine it over 600 million kilometers from our planet. Are moons that generate heat as they make their revolution, causing the ice to melt and underground oceans to form, ideal for the development of life? A far-fetched idea? Perhaps not, as Europa is not the only moon that could fit this model. Ganymede, or Jupiter 3, is the third Galilean satellite. Its orbit lasts about 7 Earth days. It is not only Jupiter's largest satellite, but also the largest in the entire solar system. In fact, it's the satellite that most closely resembles a planet. Its diameter is 5,268 kilometers, or 3,000 miles, or 8% larger than the planet Mercury, and 2% larger than Saturn's largest moon, Titan, which we'll study later. However, its mass is only 45% that of Mercury, as it is made up of equal amounts of water ice and silicate rocks, whereas Mercury is made up solely of rocks and metals. Ganymede is just over twice the size of our moon and twice as heavy as our satellite. You can see it with the naked eye in our night sky. It's the only satellite in our solar system with a liquid metal core and its own magnetosphere. This magnetosphere was probably created by convection within the liquid iron core. Ganymede completes its orbit around Jupiter in 7 Earth days, around 1 million kilometers from the gas giant. Its orbit is slightly eccentric and inclined to Jupiter's equatorial plane. Its rotation is controlled by Jupiter's gravitational tidal effects, like Io and Europa, so it too is in synchronous rotation. When Ganymede makes one complete revolution around Jupiter, Europa makes 2, and Io 4. Ganymede is therefore in orbital resonance with the other 2 Galilean moons. Ganymede's atmosphere is thin and contains several elements: atomic oxygen, dioxygen, and possibly ozone, as well as atomic hydrogen in small proportions. Pioneer 10 was the first probe to take a close look at Ganymede. In the 1970s, the American probes Pioneer 10, Pioneer 11, and Voyager 1 and 2 provided some insight into Ganymede. Then, the Galileo probe refined some of the data we have on this Jovian satellite, thanks to 6 close flybys between 1996 and 2000. Thanks to Galileo's data, we were able to discover its underground ocean and magnetic field. Like Europa, Ganymede is thought to have an ocean under its surface ice, which could contain more water than all the oceans on our planet put together. 1/3 of the satellite's surface is covered by 4-billion-year-old impact craters, and 2/3 by lighter-colored regions cut by wide grooves. This relief is probably the result of tectonic activity, triggered by tidal heating, although for the moment it remains a mystery to scientists. Some researchers believe that Ganymede has an ocean sandwiched between two layers of ice, while others think that there are several layers of ocean separated by different layers of ice, a bit like a mill fuel of water and ice. Ganymede's magnetic field is due to its iron-rich liquid core. As the magnetosphere is essential to protect us from radiation coming from space, the existence of this magnetic field is an argument in favor of the presence of life on this moon. Ganymede's magnetic field produces polar auroras, as shown by images taken by the Hubble telescope in 1995. Another feature of this magnetic field is that it is contained within the larger magnetic field of Jupiter. Studies of Ganymede's magnetic field by the Galileo probe show that there could be a multi-layered salty ocean beneath the ice crust at a depth of at least 200 kilometers or 125 miles. Multi-layered because this ocean could have up to 4 layers, each with its own salinity and density. These 4 layers would be separated by ice. On the surface of Ganymede, Galileo's high-resolution spectroscope has revealed the presence of a large number of non-aqueous materials. These include carbon dioxide, sulfur dioxide, sulfuric acid, various organic compounds, magnesium sulfate, and sodium sulfate. These materials probably originate from Ganymede's subglacial ocean, although it is not yet known by what mechanisms these compounds could have reached the surface by penetrating the satellite's crust. Researchers believe that Ganymede may have formed by accretion, i.e., the progressive agglomeration of the gases and dust that surrounded Jupiter after its formation. The average surface temperature of Ganymede is minus 148 degrees Celsius or minus 234 degrees Fahrenheit. A decay process inside Ganymede would heat the satellite even more, so that the core would have an average temperature of 1200 to 1400 degrees Celsius or 2550 degrees Fahrenheit. The presence of oxygen in Ganymede's atmosphere is not in itself proof of the presence of life on this satellite, as molecular oxygen can result from the decomposition of water ice under UV light. During this process, hydrogen evaporates into space, and oxygen, a heavier element, is deposited on the surface. For the moment, nothing is certain, but Ganymede remains a moon to keep a close eye on in the quest for extraterrestrial life in our solar system. We're now going to explore Jupiter's last Galilean moon, Callisto. Callisto, or Jupiter 4, is the second largest Jovian moon after Ganymede and the third largest in the solar system. It is the Galilean moon furthest from Jupiter, and therefore the only one of the 4 not to be in orbital resonance. Like Ganymede, Callisto is thought to have formed by accretion from the disk of gas that surrounded Jupiter after its formation. With a diameter of 4,820 kilometers or 3,100 miles, Callisto is roughly the size of Mercury. This moon has a thick crust of ice, 80 to 150 kilometers deep. It is made up of roughly equal parts rock and ice. However, it has one major difference from Ganymede. It does not undergo tidal heating and is therefore only partially differentiated. In other words, it does contain layers at different densities, but not at full depth. According to data collected by the Galileo probe, Callisto may have a small silicate core and an ocean of liquid water more than 100 kilometers beneath its surface. As on Ganymede and Europa, this ocean could harbor life. Its depth is estimated at between 50 and 300 kilometers, depending on the model, and its temperature would be around minus 20 degrees Celsius or minus 4 degrees Fahrenheit. Because of the high pressure, the water in this ocean would remain liquid. But beneath this ocean probably lies a layer of ice 300 kilometers or 185 miles thick, and a core composed of ice and rock. Callisto's surface is old, heavily cratered, and shows no sign of tectonic activity. Because Callisto is further from Jupiter than the other Galilean moons, its surface is less affected by the gas giant's magnetosphere. Callisto is surrounded by a thin atmosphere composed mainly of carbon dioxide and probably molecular oxygen, as well as by an intense ionosphere. Explored on numerous occasions by space probes such as Pioneer 10 and 11, Galileo, and Cassini-Huygens, Callisto is often considered the most suitable body for a human base to explore the Jovian system. However, the likelihood of this satellite harboring any form of life is lower than for Europa or Ganymede. The impact of Jupiter's tides is not enough to properly deform the satellite, as Callisto is located too far from Jupiter. As a result, the satellite cannot draw much heat from the gas giant. What's more, Callisto is made up mainly of ice, whereas it would be preferable for water to be in contact with hard rock to be saturated with the elements necessary for the appearance of life. In fact, the low diversity of chemical compounds and low temperatures on this satellite considerably reduce the chances of life appearing and developing. But this possibility should not yet be totally ruled out. Unfortunately, no more is currently known about the possibility of extraterrestrial life on Jupiter's moons. These moons have been explored only briefly, by spacecraft en route to another destination. But more recently, projects dedicated to the study of Jupiter and its moons have emerged. NASA's Juno probe arrived in Jupiter's orbit in July 2016, and has since delivered extraordinary images of the gas giant. In July 2021, it moved on to study the Galilean moons. On September 29, 2022, it flew very close over the moon Europa, passing just 352 kilometers or 220 miles from its surface. This was only the third time a probe had flown over this satellite. The flyby enabled the probe to take photos of the moon, as well as samples, to be compared with Galileo data collected at the beginning of the century. On October 16, 2023, images of Io were revealed by the American probe, which passed within 11,645 kilometers, or 7,500 miles of the moon. The European Space Agency's JUICE project is also eagerly awaited. Its aim is to study Jupiter and the 3 Galilean moons that could harbor life: Ganymede, Europa, and Callisto. JUICE stands for Jupiter Icy Moons Explorer. The probe was launched on April 14, 2023, and is scheduled to arrive in orbit around Jupiter in 2031, after a 7.5-year journey. This positioning will enable it to fly repeatedly over the Galilean moons to collect data. Researchers have high hopes for this project, because if all goes well, it could considerably enrich our knowledge of Jupiter and its satellites. In December 2034, the probe will orbit Ganymede to study this satellite in greater depth, before completing its mission in September 2035. Another mission is being developed by NASA, this time to study the moon Europa in depth. This is Europa Clipper. This automatic probe should leave Earth in October 2024 and reach the Jovian system in April 2030. These projects are promising and should help us learn more about the presence or otherwise of highly resistant living organisms in the subterranean oceans of these moons. Researchers don't expect to find little green men on these satellites, but rather simple organisms like those found on Earth, at the bottom of the oceans near areas of volcanic activity. But it's a good start, since life on Earth probably evolved from these ultra-resistant microorganisms. Could there be other moons in our solar system with conditions similar to Europa, Ganymede, or Callisto, suitable for the appearance and development of life? The Cassini-Huygens space mission was designed to answer this question. Its objective? To explore the Saturnian system, i.e., the planet Saturn and its satellites, determine how Saturn's rings were formed, and inspect some of the giant planet's moons. This mission, developed by NASA with the participation of the European Space Agency and the Italian Space Agency, was launched on October 15, 1997, and ended on September 15, 2017. After flying past Jupiter on December 30, 2000, the probe was placed in orbit around Saturn on July 1, 2004. On January 14, 2005, the Huygens lander detached from the probe and landed on the surface of Titan, Saturn's largest moon, while the Cassini orbiter continued to collect data on Saturn and its satellites as they passed close to the gas giant's orbit. The mission was scheduled to last 4 years, but was extended twice, ending on September 15, 2017. The Cassini orbiter was equipped with the most sophisticated instruments ever taken to the outer solar system: cameras, spectrometers. Particularly costly, this mission was a real success, as it provided scientists with a wealth of data on the Saturnian system, Saturn, its magnetosphere, its rings, Titan, and the other satellites of this giant planet. Thanks to the Cassini-Huygens space mission, Saturn's rings have been revealed in detail for the first time. These rings stretch for thousands of kilometers, yet in some places they are no thicker than a few dozen meters. The Cassini probe has confirmed that these rings are made up of billions of shiny particles of almost pure water ice. These particles vary enormously in size, from a speck of dust to a mountain. The data collected has also made it possible to date the rings. They were created less than 100 million years ago and should disappear in less than 100 million years. But above all, the Cassini-Huygens mission has also enabled us to refine our knowledge of Titan and to discover astonishing features of Saturn's other moons, notably Enceladus and its geysers, clues to an underground ocean that could perhaps harbor a form of life. In all, Saturn has 146 satellites, 144 of them confirmed. It also has more than 150 helices in its rings, which could be minor moons, i.e., particularly small natural satellites. At least 150 minor moons have been detected in Saturn's rings through the disturbances they create in their environment. But researchers suspect that this is only a small portion of the total population of these objects. Saturn's satellites vary in size from less than a kilometer in diameter to 5,149 kilometers or 3,200 miles in diameter for its largest satellite, Titan, which is larger than the planet Mercury. We'll now take a look at Saturn's two most notable satellites, Titan and Enceladus. Let's begin our journey into the heart of the Saturnian system by exploring Titan, the largest of Saturn's moons. Titan, or Saturn VI, is the second largest moon in the solar system after Ganymede. It was the first moon of Saturn to be discovered by Dutch astronomer Christian Huygens in 1655. One of Titan's special features is that it is the only known satellite to have a dense atmosphere. Its atmosphere is made up of 98.4% dinitrogen and 1.6% methane and ethane, and lies between 200 and 880 kilometers in altitude, i.e., almost 500 miles above sea level. To give you a point of comparison, on Earth, 99.99% of the mass of the atmosphere is less than 100 kilometers or 60 miles above sea level. It's also difficult to obtain a spectrum of Titan's surface, as its atmosphere is opaque over a wide range of wavelengths. Titan's atmosphere contains layers of opaque fog that block out most of the sun's light, so much so that the Huygens probe team described the process of photographing Titan's surface as photographing an asphalt-covered parking lot at dusk. The temperature of the atmosphere is around minus 180 degrees Celsius, or minus 292 degrees Fahrenheit, and reaches minus 200 degrees Celsius, or minus 328 degrees Fahrenheit, at the tropopause, at an altitude of 40 kilometers, or 25 miles. According to observations by the Voyager probes, the pressure at the satellite's surface exceeds 1.5 times that of the Earth. Titan is composed mainly of rock and frozen water. Its surface is geologically young, with a few mountains and cryovolcanoes, but overall, a relatively flat and smooth surface, with few impact craters. Winds and methane rains, which are frequent on Titan, create dunes and coastlines on the satellite's surface, just like on Earth. Titan also has seasons. When Cassini's Huygens module visited Titan in 2004, it detected elements of life in its atmosphere. But that's not all. As it flew over the moon, it detected something mysterious, partly hidden by the clouds gathering over its south pole, resembling a lake of water. Numerous flybys subsequently revealed the existence of hundreds of such lakes, scattered across the moon's north and south poles. What is the significance of these mysterious lakes? Could it be that, as on Earth, they are lakes of water with a rich ecosystem? This question has intrigued researchers, as Titan is the only known environment other than Earth to feature liquid expanses on its surface. But given Titan's surface temperature of minus 180 degrees Celsius or minus 290 degrees Fahrenheit on average, these lakes cannot be lakes of liquid water. After analyzing the infrared waves reflected by the lakes, the researchers concluded that they were in fact liquid methane and ethane at very low temperatures. On Earth, these elements are used as fuel in gaseous form. But on Titan, liquid methane digs valleys, forms clouds, and falls as rain. In fact, it behaves exactly like water on Earth. Researchers then wondered whether this methane could be conducive to the formation of life, allowing organic molecules to dissolve, mix, and interact, just like water on Earth. Our theory of life includes the need for a liquid element. On Earth, water enables organic molecules, the basic ingredients of life, to dissolve, assemble, and interact with each other to form larger, more complex molecules, destined to develop into living beings. But could another liquid do the trick? Could the building blocks of life dissolve in methane and give rise to life? Astrobiologist Chris McKay has attempted to answer this question. To do so, he used the elements detected in Titan's atmosphere by the Cassini mission and carried out a simulation. First, he reproduced the reaction that takes place on Titan to obtain the same organic material as in its atmosphere. Next, he recreated the lakes, detected by the Huygens module's radars, by filling a test tube with methane gas, which he cooled to minus 143 degrees Celsius or minus 225 degrees Fahrenheit using liquid nitrogen. The methane liquefied exactly as it does on Titan's icy surface. Chris McKay was thus able to obtain a miniature Titan lake in his test tube, namely, a bath of liquid methane with organic materials. The aim now is to find out whether these materials will dissolve to form more complex molecules and ultimately a new form of life. If these organic materials can dissolve, it means that the chemical processes necessary for life could exist on Titan, and on a larger scale, that they are capable of being triggered even in conditions of extreme cold and in liquids other than water. This would also mean that life has arisen twice under different conditions, and that it is therefore a natural process that can appear in other places. This would open up infinite possibilities. In any case, if there is life on Titan, it bears no resemblance to life on Earth. While we await the results of Chris McKay's experiment, other evidence of possible life on Saturn's satellite has been put forward. A team of researchers has identified a deficit of acetylene on Titan's surface. This molecule, which forms on the planet's surface, should be present in Titan's lakes, but has not yet been detected. According to Chris McKay, acetylene could indeed be the food of choice for hypothetical life based on liquid methane, but nothing is certain yet. The lack of acetylene could just as easily result from the action of sunlight or cosmic rays, which are capable of transforming acetylene into other, more complex molecules that no longer display its spectral signature. Whatever the case, researchers are still hopeful of finding some form of life on Titan. This moon of Saturn closely resembles a primitive Earth, albeit at a lower temperature in many respects. Its liquids on and below the surface, its thick atmosphere of diazote, Titan could well contain extraterrestrial microbial life, or at least a prebiotic natural environment rich in complex organic chemistry. Another of Saturn's moons has attracted the curiosity of researchers, Enceladus. On the face of it, this satellite isn't the most interesting. It's only Saturn's 6th in size and 14th in distance. But since the Voyager 2 and Cassini-Huygens missions, researchers have been taking a close interest in this small moon, which boasts some astonishing features. Enceladus is a real mystery, very different from Saturn's other moons in its appearance and shimmering white surface. It displays a complex geological activity, difficult to explain for such a small body. Indeed, Enceladus measures only 500 kilometers or 310 miles in diameter on average. However, the Cassini probe has spotted cracks, protrusions, and fissures on its surface, showing that there has indeed been activity on this moon. In fact, one of the objectives of the Cassini-Huygens mission was to find out whether this geological activity was still taking place today. Take a close look at these images taken by the Cassini probe. You can see 4 strange blue faults running parallel down towards the South Pole. These faults have been nicknamed the Tiger Stripes. 120 kilometers, or 75 miles long, they are several hundred meters deep and bear disturbing similarities to earthly faults. The probe's thermal sensors recorded some surprising data at Enceladus's South Pole. While these faults should be colder than the rest of the moon, they radiate heat. In fact, the faults are on average 95 degrees Celsius or 200 degrees Fahrenheit hotter than the rest of the moon. The mystery surrounding Enceladus thickened when the probe changed its perspective. As Enceladus passes in front of the sun, immense geysers can be seen, erupting from the Tiger Stripes. These immense jets of matter rise up to hundreds of kilometers. So, does Enceladus harbor an energy source like Io or Europa that could explain these geysers? The answer is yes. Like the 2 Galilean moons, friction generated by gravitational forces causes the moon to heat up and melt ice. As it approaches Saturn, the moon Enceladus undergoes a torsion that creates internal heating, exactly what happens when a piece of metal is bent. The jets observed by the Cassini probe are in fact liquid water vaporized in space, freezing on contact with its icy temperature. These jets are propelled at an impressive speed of nearly 200 kilometers per hour or 125 miles per hour. So there could be liquid water beneath the surface of Enceladus. The Cassini-Huygens space mission team programmed the probe to pass through these jets in order to sample particles and better understand their origin. After several passes, the probe detected some of the elements that make up living organisms. The discovery confirmed that yes, there could be life on Enceladus. The moon contains 3 elements needed to be considered potentially habitable: liquid water, a powerful heat source, and organic material. What would life be like on Enceladus? Around the Tiger Stripes, we'd be in a region of eternal snow, since it's been snowing on Enceladus for at least 100 million years. The sky would be black, and we'd have the impression of floating due to the low gravity. We wouldn't be able to see anything with the sun at our backs, but facing the sun, we'd be able to see the immense geysers cut through the light and fall to the ground in a thick white mantle. For the moment, there is no evidence that Enceladus harbors life. Cassini's instruments have not detected any trace of life as such. But Enceladus is definitely on the list of next destinations to visit during space exploration missions. What's more, to analyze the moon's underground water content, you don't have to dig as you do on Europa. Just walk through the geysers. All the particles are sent into space, ready to be collected and analyzed. Apart from the Saturnian and Jovian systems, are there any other moons in our solar system that could potentially be habitable? Of the 214 moons identified by NASA, there must be more. To answer this question, scientists have turned to Uranus, Neptune, and Mars. Uranus and Neptune were overflown in the 1980s by the Voyager 2 probe. Scientists held out little hope of the habitability of these icy planets, which could not harbor liquid water, but after the discovery of oceans in unlikely places, the data collected on these planets and their satellites was revised. Uranus has 27 moons, but only 5 have been analyzed in depth: Titania, Oberon, Umbriel, Ariel, and Miranda. If an internal ocean existed on Miranda, the smallest of the satellites studied, it would probably have frozen over by now. But it's entirely possible that the other 4 moons contain an internal ocean. Depending on the moon, scientists have developed different scenarios to explain the origin of an energy source. On Titania and Oberon, the 2 largest satellites, heating is thought to be due to the tidal effect of Uranus, while on Ariel, it could be explained by cryovolcanic activity. The scientists' conclusion is that there may be internal oceans on the Uranian satellites, but they are relics of former oceans, or residual oceans, rather than thick oceans. And what about Neptune? The 8th planet from the Sun, Neptune, like Uranus, is what we call an icy planet. Of its 14 satellites, the one that most interests researchers is Triton, its largest, with a diameter of just over 2,700 kilometers, or 1,700 miles. Triton is an astonishing moon. It's the only known large satellite in the solar system to orbit in the retrograde direction, i.e., in the opposite direction to the planet's direction of rotation. For this reason, Triton may be a Kuiper Belt object captured by Neptune. It is also the only moon, along with Phobos, one of Mars' 2 moons, to approach the object around which it orbits. Our moon, on the other hand, is moving away from the Earth by about 3.8 centimeters, or 1.5 inches per year. While flying over Triton, Voyager 2 observed geysers 8 kilometers or 5 miles high over 180 kilometers or 60 miles, all concentrated in the region of Triton, currently facing the Sun. These geysers would therefore have a solar origin. Researchers believe that Triton harbors fairly recent cryovolcanic activity, which explains the nature of the terrain observed by the Voyager 2 probe on its surface. Like Europa, Ganymede, Titan, and Enceladus, Triton could be home to an underground liquid ocean. To find out more, a mission project had been developed, the Trident mission, but it was not selected to be part of NASA's Discovery program. Instead, missions to Venus were chosen. No doubt another mission will be developed to answer the many questions scientists have about this mysterious moon. Where do its geysers come from? Why is its landscape constantly changing? Why does it have an intense ionosphere? Let's end our exploration of the mysterious moons of our solar system by getting a little closer to Earth. We're on our way to Mars and its two moons, Phobos and Deimos. These two moons share many characteristics with C-type asteroids, primitive bodies dating back to the genesis of the solar system. But contrary to what researchers have long believed, these are not primitive celestial bodies that were attracted to Mars from the asteroid belt like Triton. Not only is Mars' gravitational pull too weak, but their orbits are too circular. Phobos and Deimos are more likely to be the result of a collision between Mars and a giant celestial body. Perhaps these two moons were born at the same time, but their trajectories are different. Phobos is approaching Mars by around 2 meters every 100 years, while Deimos is moving away. In fact, Phobos is the closest satellite to its planet in the entire solar system. Its surface is dotted with craters, fissures, and other marks left by meteorite impacts. According to the researchers, Phobos will be destroyed in 30 to 50 million years due to deformations caused by Mars's tides and gravity, while Deimos will probably move away and emancipate itself from Mars' gravitational pull. In any case, these two moons are unlikely to harbor life. In the quest for extraterrestrial life, it's Mars that interests researchers. Europa, Ganymede, Callisto, Titan, Enceladus, Triton. All these moons could be inhabited by forms of life we can't yet imagine. Research carried out in recent years on the moons of our solar system has shown us that there are worlds not so far away from us that are very different from our own, and yet could be home to extraterrestrial life forms. But is life on these seemingly cold and hostile moons possible? On Earth, we've discovered that life can cope with far more extreme conditions than previously imagined. Some microbes can live in arid deserts, in lakes saturated with arsenic, or on the walls of caves dripping with sulfuric acid. Environments that are toxic for us can be conducive to the development of other types of living beings, ultra-resistant organisms, unsuspected forms of life. Everywhere on Earth, life manages to thrive. So why not in underground oceans, sandwiched between several layers of ice and maintained in a liquid state by an internal energy source? Recent discoveries have prompted researchers to rethink their models and re-examine what they already know. Worlds that had previously been considered too hostile are now being re-examined and analyzed from a different angle. Whereas before, the search was for Earth-like planets, the field of possibilities has been broadened by looking at other types of celestial bodies, which offer other conditions and environments, and which may favor different types of chemical processes, with a result that could well be life.